Welcome to the Training Stimulus podcast. Today we have a phenomenal episode in store for you. We're joined by a very special guest, Mr. Seale from Upside Strength. Sean is a world-class expert in all things conditioning. We've previously done an episode on Zone 2, which I'll link in the description below. Very, very worthwhile checking out. But I wanted to do a bigger picture view on conditioning, how to get people fitter. In this episode, we're going to review the old traditional model of the three energy systems, which is pretty outdated now. We'll look at some newer, better models, including physiological limiters. And then we're going to finish up with what Sean thinks is the best way to think about getting people fitter, endurance training, and the practical ways you can apply that in your own training, but also for your clients or athletes if you're a coach as well. If you've seen the episode length, it is a long one, but I assure you it's very well worth your time. Sean knows this stuff inside out, and you can tell by the level of detail he's able to go into just off the cuff. And we've added some slides to the video to bring these concepts to life. So I'd highly recommend you watch this if you can. But if you can't, don't worry. I'll add a link in the description where you can download the slides, which will help you understand what's going on and hopefully commit this stuff to memory as well. It is a bit technical at times, but please push through if you find it challenging or not that familiar with this type of stuff, because there are tons of simplified and well summarized bits which will leave you leaving the episode with a huge amount of practical takeaways to benefit your own training and your clients. But that's more than enough from me. I'll let you guys enjoy the episode. Let's get into it. Sean, how are you doing today, mate?
Ash, I'm doing really, really well. The sun is shining. It's a beautiful day, and I'm happy to be on the podcast with you.
Really glad to hear it. I wish I could say the same. I think there's a few rumbles of thunder, which is not what you like to hear, but yeah, it's warm at least. So thank you very much for your time. Excited to talk to you. So the topic today, I'm calling it the new world of conditioning. After our successful Zone 2 podcast last time, I wanted to pick your brains on the wider world of conditioning for a more like a high level view of how the various different models of conditioning have evolved over time, and get your thoughts on the latest picture for conditioning. So I thought a good place to start would be the evolution of these traditional views. So, aerobic, anaerobic, creatine phosphate. Could you tell us why that model has sort of fallen away or lost relevancy in the new world?
Yeah, I think it's a good starting point. So what I learned when I started reading about training and about bioenergetics was those three energy systems, right? And obviously the main goal of those energy systems is to put ATP back together, adenosine triphosphate, which is the energy currency of the body, one of them. And those energy systems are there to just put it back together, because we essentially break it down when we contract muscle, or essentially any energy you require in the body is going to go through those pathways, whether it's maintaining cellular structures, creating new proteins, or again powering mechanical work, so muscle contractions, for example. And so the traditional model that I was introduced to, and a great book that I read early on, was Ultimate MMA Conditioning from Joel Jamieson. And I think you could take the MMA out and call it Ultimate Sports Conditioning. I think it was a good overview. And the beginning about energy systems, when he describes the three systems, is something that was always fascinated by, and trying to understand the mechanistic aspect of how the body works. I definitely think that you don't need to understand all those things in detail to be a good coach, right? But if you're curious, then trying to tie together what's happening in the field and then what's happening inside the body is super interesting. And so the let's call it the old model of bioenergetics is that you had that traditional graph with those three energy systems that sequence each other in time, where you typically have the creatine phosphate that seems like it's full at the beginning, and then it goes down over 10 30 seconds, and then it flatlines, and then it stops being used. And then you have the glycolytic pathway, which essentially the breakdown of sugar, and that creates ATP as well, or recycles ATP as well. And then you have the aerobic component that typically take a longer time to start rising, and then it would be the main system after a period of time. And so that's kind of the traditional or the old model of bioenergetics. And what I started understanding when I started following Evan Pycon many years back now is that those energy systems aren't separated in time, or nowhere as much as they could be understood to be in that graph format. And one of the things that Evan put forward, and everything well documented in the literature, and papers that have been out for 20, 30 years. It's not like it came out last year and it's a brand new thing. We've known that for a while. And the main thing is that all energy systems are active within 150 milliseconds, I think, of a muscular contraction. So it all turns on right away. That's the first thing to understand. So that would be one major departure from the old model where we sequence them in time. And there was also this view of training, and that's something that was put forward in Joel's book, is that essentially depending on the time domain of your training, you're going to target different systems, right? So if you do really short intervals, you're going to target the phosphocreatine system. If you do 30 seconds to 2-3 minutes, you're more in the glycolytic pathway. And then if you do the longer stuff, you're more in the aerobic pathway. And so we have those three systems. The first two that are coined anaerobic because there's technically no oxygen in the chemical process of those pathways. And then there's the aerobic system on the other side, which obviously has oxygen as its main, or as an important contributor to the process. But again, all those systems work together. They all turn on pretty much instantaneously as soon as you start any kind of muscular contraction or mechanical work. And what I found after this as well is that they look separate on paper. So if you write down the equations, obviously they're different equations, they're different systems, quote unquote. But once you start paying attention to where they exist, those energy systems, and how they work, they actually all work together in one way or the other. And so I think it's interesting to think about where those energy systems exist, which is inside the muscle fiber, right? Inside the muscle cell itself. And then inside the cell, you have things called myofibrils, which are the contractile elements of the fiber. And then you have the mitochondria, which is often coined the powerhouse of the cell, right? And from more recent research, we know that it's not only the factory for energy inside the cell, it seems to also be the power grid. So there's a lot of energy transfer that goes through the mitochondrial system. And we see mitochondria as like a little floating object inside the cell, but it's actually more like a network. And there's imaging that we have now that really shows how it's all part of the architecture and the structure of the cell itself. So it's literally like a power grid holding everything together, moving energy from one side to the other. And obviously, if we take those contractile elements in the middle of the cell, they're going to need a lot of ATP in order to contract, relax, right? And especially, typically, it's actually the relaxation phase that requires a lot of ATP, because the contraction happens through the calcium, the interaction of calcium with is it the troponin, I think, that kind of moves aside, and the myosin head binds and then pulls. But without going too far into this, coming back to the energy side of things, and I'll start with the creatine phosphate pathway, or the phosphocreatine energy system. So we call this one alactic anaerobic. Alactic because there's no lactate produced or involved, and anaerobic because there's no oxygen involved. And the way I like to frame the phosphocreatine system is like a bathtub. So when you're resting, the bathtub is full, and obviously the plug is in, and the tap is running just a little bit. They're just kind of dripping, right? And this is kind of your basal metabolic rate. So it's just the energy that you need to keep things going, but there's no major work being produced because you're at rest. And essentially, it's a buffer. It's an energy reserve that you have inside your cells. And as soon as you start an effort, the first thing that it's like pulling the plug out of the bathtub. and then that bathtub starts draining. And the more intense the effort, the bigger the drain hole, right? And so you have that reserve, you have that bathtub that starts emptying itself as soon as you start exercise. But then what happens? We need to fill up that bathtub because we know that phosphocreatine is the fastest means of putting ATP back together. And we have to go through that pathway most of the time in order for it to work. Otherwise, other pathways are a little bit slower, quote unquote, especially the aerobic pathway. And there's also, if we go back to this idea of where things happen, there's also the fact that ATP that's produced inside the mitochondria through the oxidative pathway cannot diffuse from the mitochondria all the way to the contractile elements in the cell. The distance is too far. It's just not efficient. So the body developed something called, or evolution, I guess, made happen something called the phosphocreatine shuttle. And actually, if you, and this is nothing new. You can dig onto PubMed and you'll find all that information. What happens is that ATP is produced inside the mitochondria through the oxidative process. That ATP is then used to put phosphocreatine back together because we had phosphocreatine. It broke, right? Because we put the phosphate back onto the ADP to make ATP again. But then we need to put phosphocreatine back together at some point, right? That actually happens inside the mitochondria with the ATP that is produced through the aerobic pathway. And then that phosphocreatine that's been put back together inside the mitochondria then gets diffused out towards the contractile elements. And this is called the phosphocreatine shuttle. So already here, we can see that if there's no oxygen available, there is no recomposing of the phosphocreatine system. So that bathtub essentially needs to be filled up by opening the tap. And the tap is the energy that comes from the mitochondria itself, right? So already we can take that anaerobic alactic system and realize that sure, we have that reserve at the beginning, and then you start exercise and it starts going down. And the way you have to understand it is that phosphocreatine is always the intermediate between the oxidative system and the muscle contractions, meaning that even though after if you go into hard effort right off the bat, for example, the bathtub, the water level is going to go down really fast, but then the drain is fully open and the tap is fully open. So even though the concentration level of phosphocreatine in the cell is low, the flux is really high because we have to go through that bathtub in order to keep using the ATP that was made in the mitochondria. And that's, I think, one big departure from the typical graph that we see with energy systems, right? We see phosphocreatine is used in the first 10, 20 seconds, and then it goes to zero, and then it's not used anymore. That's not true. It keeps being used all the time. And then obviously, if you stop exercising, it's like putting the plug back into the bathtub, and now it fills back up thanks to what? The oxygen, the mitochondria. And then when it's full, the tap closes, your bathtub is full, and you're ready for the next bout of exercise. Right? So already we can see that phosphocreatine and oxidative work together, and they might as well be one and the same. Obviously, chemically, if you write down the equations, they're not together, but functionally inside the body, they work as a pair. So that was one big realization that I had learning from Evan. And then if we start to add in the glycolytic pathway, glycolysis happens inside the cytosol of the cell, so inside the kind of the body, inside the main space inside the cell. And it does produce ATP pretty quickly, but then comes with it the byproduct of glycolysis, which is typically lactate. There's a balance between lactate and pyruvate, but we know now that it's mainly lactate and then a little bit of pyruvate. And then depending on the capacity of the cell, it's either going to be recycled fully in the mitochondria, or if it can't fully be recycled by the mitochondria, it's going to be put back into the blood, into the circulation, to go and get used somewhere else. Our brain uses lactate, our heart uses lactate, every muscle can use lactate, because essentially the mitochondria takes lactate and then it's broken down through the Krebs cycle, and then that feeds the electron transport chain, right? So if we go back to the mitochondria for a second, inside the mitochondria, we have those kind of two main stages. We have the Krebs cycle that happens inside the mitochondrial matrix. So it's going to take, to simplify, it's going to take pyruvate or lactate, or whatever comes out of beta oxidation, so the breakdown of fatty acids, and it's going to feed that into the Krebs cycle. And then from this process, we're going to get a little bit of ATP, we're going to get some CO2. This is where CO2 is produced inside the metabolic process. And we're going to get the NADH and the FADH2. And those two molecules, we can think of them as electron transporters, right? And then those feed into the electron transport chain, and then that creates the proton gradient, and then that generates ATP with oxygen that comes in at complex 4 of the respiratory chain. And then, so going back to glycolysis, that happens inside the body of the cell. So now we come out of the mitochondria. We're back into the main body of the cell. Like I was saying before, and if we start working in different intensities, it might be helpful. So typically over the intensity spectrum, I would say there's 4 different intensities of exercise on the endurance side of things. There's low intensity, medium intensity, high intensity, and very high intensity. And we can come back to those later and break them apart and introduce concepts like thresholds. But for now, let's just think that there's 4 levels. Okay, that's the simplest way to think about it. So when you're at level 1, when you're at low intensity, your lactate production through glycolysis is fairly low. It's always going. Even right now, if we prick your finger, you're, I don't know, maybe at 1 or 1.5 millimoles of lactate. So glycolysis is always active. It's wrong to say that there's no sugars being used at low intensity. They are used, but obviously less than when you're at higher intensity. But anyway, glycolysis is happening at low intensity, but essentially you have more mitochondria than you need to recycle the lactate that's produced. And so what happens with the lactate in the blood, it either stays the same or goes down, right? So let's say you're at 1.5 millimoles measured in the blood right now at rest. I get you to start exercising at a low intensity. After 2 or 3 minutes, I prick your finger again, and you might actually come down to 1, maybe even 0.5, right? Because you're producing very little lactate inside the cell because you're preferentially using fats at that point. And so your cell is actually going to go and pull sugars from your blood to keep feeding that mitochondria, right? So that's why lactate actually drops typically at low intensity compared to baseline resting levels. So that's why, depending on the intensity, different things happen with that pyruvate lactate inside the cell. And then now if you go to medium intensity, so that would be between the 2 thresholds, right? That would be a sustained effort somewhere between, say, 4 and 7 out of 10 in terms of RPE. So it's hard in the legs. It's starting to be sustained on the breathing side, but it's still manageable, still something you can hold for quite a while. And what happens there is that you've essentially saturated your mitochondria. It can't recycle all the stuff that you produce inside the cell. So what's going to happen is you're going to recycle everything that you can through the mitochondria, okay, because that's the most efficient pathway. And then the excess that you're producing is going to go into the blood. And that's what we measure when we do a lactate sample at medium intensity. So you were at 1.5 at rest, you went down to, say, 0.8 at low intensity. Now it's going to start rising back up. Maybe you go to 1.5 when you're at, say, 4, 5 out of 10 in terms of difficulty. Maybe you go to 3, 4 millimoles when you go to 6, 7 out of 10. And then if we go now over to the high intensity, so kind of the 3rd level of intensity that we can use as a model. So the high intensity VO2 max zone 5, whatever word you want to use. Now you've saturated your mitochondria locally. So we can't recycle everything that's produced. And even what you put out in the blood can't be recycled properly everywhere else because your global capacity is just not sufficient anymore. And this is when you kind of have that runaway effect where lactate starts increasing fast, heart rate increases fast, VO2 increases fast, and you trend towards task failure. Typically, you have to slow down or you have to stop. And so again, if we go back to the energy systems, glycolysis feeds directly into the mitochondria. So glycolysis feeds directly into the aerobic system. So again, nothing works in isolation. And if we want to take a 30,000 foot view now of everything that I said, and if things were a little bit technical, I encourage you to listen to it again, maybe go read some stuff on it. I didn't understand any of this when I started looking into it, and it just takes repetition like anything else to get it. But the 30,000 foot view is that nothing works in isolation. All those systems work together. And so I feel like the model of training energy systems is not as useful as thinking about those 4 levels of intensity: low, medium, high, very high intensity. And that this model, and again, all models are wrong, but some are useful. And I find the intensity spectrum model a lot more useful when it comes to talking about endurance and talking about training than just thinking about energy systems, because again, they all work together. And obviously, like you saw, at different levels depending on the intensity that you're at. But it's actually not practical, I find, to think about, okay, I'm going to train that energy system with that time frame or that energy system with that time frame. So coming out actually of the kind of mechanistic physiology and just focusing on, okay, am I at low intensity, medium intensity, high intensity, or very high intensity? That tells me what is going on, tells me what adaptations I'm going to get, tells me how to structure my training, tells me how to organize different phases of training depending on when I am in the season. And it's a lot more useful to think and to program. So understanding all the physiology is cool. It's if you're curious, it's super interesting. But you have to tie it back in with the intensity spectrum, with the thresholds, with those 4 different levels to make it really practical and useful.
Definitely. That's an amazing explanation. And I would echo what you said there, that everyone should re-listen to that to really get familiar with the intricacies of it. I think one of the phrases I heard that helped this make sense to me was, there is one energy system. It's just you produce energy, and that's kind of it. And like you say, when it comes to practically applying our knowledge of this, the intensities make so much more sense. And yeah, align with the intended outputs of any training block far more than thinking, oh yeah, I've spent a good amount of time working on my glycolytic energy system this week. Like, what does that really mean, and how does that get me closer to my goal? So that's a really good expose on the old school 3 energy systems view. And you mentioned Evan Picon. I wanted to hear a bit more about his view of the limiters that we've spoken about before, because I think that resonated with me when I heard about it as well, in terms of how to really meaningfully target somebody's physiology in the way that would yield the most performance benefits. So could you walk us through sort of how he came up with that model, or what that model is for people who haven't heard about it yet?
So like I said at the beginning, Evan has been probably if I had to give one name that pushed me in that direction, it's definitely him. So I'll be eternally grateful to him for everything that he's put forward over the years, and I've learned a ton from him. And I was also very interested by his model of performance limiters or limiting systems. And the main idea was that, and obviously, think our models and perspectives change over time, and I'm not consistently reading what Evan's putting out these days. So if his model has changed and evolved, then I'm happy to hear about it. But what I'm giving here is kind of what I remember from what I remember learning from him a few years ago. And the main idea was that you have those 3 main systems when it comes to energetics: the respiratory system, the cardiovascular system, and the muscular system. And obviously, all of those interact when you do any type of exercise. And the idea is that one of those systems is typically your limiting factor. And so if you can assess which system is limiting you currently and then train that system specifically, you'll be able to improve and then maybe find a new limiter, right? So it's always kind of attacking that low hanging fruit. And then once you pick that one, obviously there's another fruit to go and pick after that. And so the body is dynamic and it changes over time. And then what you need to work also evolves over time, which we know is true because you might do a training for 8 weeks, 12 weeks, 16 weeks on a given quality and it yields great results. And then just doing it over again just after, it doesn't guarantee that you'll get the same improvement as before. Typically, it's even almost guaranteed that you won't get as good an effect as before, simply because the body accommodates to the stimulus, right? Adaptation is one of the main principles of sports preparation, physical preparation, and just all living bodies adapt to the stimuli that they're confronted to. And anything that's new is going to have a bigger effect than things that you've been doing for weeks or even months. That's why sometimes the best training you can do is just something different.
Yeah.
especially if you've been doing the same thing over and over and over again. At the beginning, it works really well. Towards the end, it's a bit more difficult, and you're putting a lot of energy into it. So back to those limiting systems from Evan's model, the idea was that through different types of testing, and one thing that I learned thanks to Evan, amongst others, was using the Moxie monitor to do some physiological testing. This is where everything started for me when it comes to that testing. And with the Moxie, you could assess different things inside the muscle itself. The Moxie is a measurement tool that is non-invasive, so you just essentially put it on the muscles like a patch, and it's going to essentially measure the oxygen transporters, so the hemoglobin and the myoglobin, the kind of cousins. If you look at the molecular structure, it's like hemoglobin is composed of almost 4 myoglobins. And so if you break a hemoglobin into 4, you have essentially a myoglobin. Myoglobin is in the muscle, and it's going to store and transport oxygen inside the muscle. Hemoglobin is inside your red blood cells, and it's going to transport oxygen from essentially your lungs to the muscles or to any part of your body that needs it. And so that Moxie measures those two transporters, hemoglobin, myoglobin, inside the capillaries of the muscle. And it's essentially going to say, okay, out of 100, and I like to call them like taxis or cabs. So they're there to transport oxygen. And in a cab, you have typically 4 spots. Hemoglobin can transport 4 oxygens. Myoglobin can transport 1. And out of 100 cabs, how many are full and how many are empty? Because you can't just have one oxygen molecule inside a hemoglobin. It's either going to be 4 or it's going to be 0. And it just measures the 100 cabs, and it says out of 100, how many are full, how many are empty. And it gives you that information twice a second. And so you can see essentially on a continuous basis the saturation level, the oxygen saturation of your muscle. And the number is somewhere between 0 and 100. It's like a 100% scale. And at first you tend to get fixated on the numbers, and if you have 2 monitors, you'll put one on the left leg, one on the right leg, and you say, oh, I'm at 60 here, but I'm at 50 there, what's going on? The number itself is not very important, at least not at the beginning. What's interesting is to see the trend and how the curve essentially of the saturation is trending. And one thing that I discovered 2 or 3 years after I started using the tool with another colleague called Jem Arnold, I highly recommend all his work. He's doing a lot of research with the Moxie and other NIRS devices, is that essentially the light, which is an LED light that is used to go and measure those transporters, well, it penetrates the muscle. I forget if it's 1.5 centimeters or if it's millimeters. It's pretty short distance, right? It doesn't go down to your bone, kind of thing. It's pretty shallow, quote unquote. And what we saw on those different trends, and if we go back to the intensity spectrum that I mentioned before, so the low, medium, high, and very high intensity. Typically, when you do a physiological test, you're going to try and cover the first 3 levels. So you're going to cover low intensity, medium intensity, and then high intensity. And then there's different protocols that exist, 5-minute intervals, 4-minute intervals, with rest, without rest. But at the end of the day, one of the main goals of physiological testing is going to be to break apart those different levels. What is low intensity for you? What is medium intensity for? What is high intensity for you? And then obviously, what can we do with that information, and what should you train, right? Because there's what is, and then what you should do. And the data doesn't always tell you what to do. It tells you what is, but then you have to use your brain and think and use your coach's eye to determine what we're going to work on. And going back to that Moxie, one thing that was challenging at the start is that there was different trends emerging depending on the person that I tested or even the muscle group that we were measuring. So if we take those 3 intensity domains, and I'll give you the visuals so it'll make more sense. Sometimes at low intensity, the trend went up, the oxygen saturation went up. Medium intensity, it flatlined. It stayed stable, let's say. And then at high intensity, it started going down again. So it had the kind of hyperbolic trend. So sometimes this is how it presented itself. But other times, it was flat at low intensity, around maybe 50, 60% mark. Then it would go down at medium intensity, and then would flatline way at the bottom, maybe at 20 or 10% saturation at high intensity. And I couldn't and then one of the main the early thoughts with Moxie testing was that if you had that kind of parabolic trend, so the kind of up, flat, down, that you had a sufficient supply of oxygen, and so we would call that utilization limited, or more limited by your muscles' ability to extract oxygen, right? Whereas if you had the other trend, so the flat, down, and then flat again, we would say that you're delivery limited, because you can use all the oxygen that you have available, but you can't deliver enough. And so that was kind of one of the main frameworks, thinking about this, doing the testing and saying, oh, okay, so your curve goes up, flat, and down. So we need to work on your muscles' ability to extract more oxygen. We can use sprint training and some other approaches like this. And then on the other side, if we see a flat, down, flat, then we would say that you're delivery limited, and we're going to work on your cardiovascular system and do more traditional endurance training. So that was the main idea. And thanks to Jem, who had some pretty advanced tech a few years back already, we actually saw that you could see both of those trends on the same person at the same time on the same device if you could measure at two different depths. Because oxygen kinetics, delivery, and utilization are different whether you're in a superficial part of the muscle or in a deeper part of muscle.
Wow.
Typically, when you're more on the surface of the muscle, you have more capillaries, and so you have better delivery of oxygen. We'll simplify it and just say this. And then if you go deeper inside the muscle, you have a little bit less delivery, and you typically have a higher density of mitochondria, which is where the oxygen is used. So to make it simple, deep inside the muscle, you use oxygen more easily, and you will deplete faster what you have available. Whereas on the surface of the muscle, or closer to the skin layer, let's say, you're actually going to typically have an abundance of oxygen, and you're not going to be able to use it all, given those parameters that I gave, right?
Wow. Can I ask a question? Sorry to interrupt. Does that help to explain the phenomenon that bigger, muscular people gas out faster because they have deeper muscles, or like thicker muscles, so they have more which is away from the surface, which would be less capillarized, and therefore might be.
So I think that trend of the superficial versus deep muscles applies to everybody. I think what you're hinting to, I would put that more on the account of their muscle fiber distribution. So how much slow twitch fibers do they have? How much fast twitch fibers do they have? And we can come back to this later because it is relevant to that conversation. Essentially, fast twitch fibers and slow twitch fibers have different strategies to optimize their output. And you can think of slow fibers as very efficient because they have a ton of mitochondria and they have a little bit less contractile elements inside of them, compared to fast twitch fibers that are really made for power, that have a lot of contractile elements, that takes up a lot of space inside the muscle cell. And so they have less mitochondria. And so they're less efficient from an energetic standpoint. Now, there's communication between those two. So the metabolic byproducts from the fast twitch can be recycled by the slow twitch. Right? Because there's a direct transfer between them, and they all work together. It's not like there's one on one side of the body, one on the other side of the body, and they don't communicate. They're typically next to each other, right? And they have a symbiotic relationship. They kind of trade skills in that way. So we can come back to that later.
Yeah, come back to that one.
But essentially, depending on how far down the light signal of the Moxie goes into the muscle is going to influence what kind of graph you get. Do you get the up, flat, down? Do you get the flat, down, flat? And essentially, you can even see it depending on the adipose tissue layer of somebody. So if somebody's really lean, you'll typically the flat, down, flat. Why? Because we're going deeper inside the muscle. If somebody's got a bit of adipose tissue, then you'll typically see the parabolic trend, because we have to go through that skin layer and adipose tissue first, meaning we're going to be measuring at a more superficial level of the muscle, right?
Wow.
So whereas at the beginning we thought that, all right, if you see that trend, you're limited by this. If you see that trend, you're limited by that. Well, no. It's just that depending on how far down we measure inside the muscle, that's what gives us those two trends. So this is where my understanding started shifting a little bit regarding that limiter system approach, because again, if I have the right device, I can show you both trends at the same time on the same muscle on the exact same person, which means that for me, it no longer is the best explanation as to what is going on and what we can do with that information, right? And then there was also some ideas around THB, total hemoglobin, which is another metric that you can get from the Moxie. So the Moxie has two outputs essentially. It's got the SMO2, muscle saturation, on the 0 to 100% scale, and then THB, which stands for total hemoglobin, and it was supposed to be essentially quantifying how much hemoglobin, myoglobin was present under the sensor. But after talking with Andrew Feldman and Roger Schmitz, who are both the co-founders and co-developers of the Moxie, they essentially told me that the THB signal was not as reliable as they wanted it to be, and that they wouldn't recommend basing too much interpretation on what was going on with THB. So since that time, I've kind of just focused on SMO2 and haven't looked at THB. I've obviously still recorded it, but I haven't spent as much time looking at the THB as I used to, following the conversation I had with Andrew and with Roger. I'm not saying that we can't find anything useful in it. I think there's some ideas around occlusions that can be relevant with THB. But I felt like the SMO2 trend coupled with lactate data coupled with RPE, with ventilation, with VO2, that was sufficient information to kind of push training forward and make decisions around the testing and the training. So that was kind of an overview of the model. And to finish and link those two together, I said the respiratory system, there was an idea that you could parse out a respiratory limitation based on the THB trend. So looking at how the THB behaved at certain intensities, you could say, oh, that guy's probably limited by his respiratory system. Today I wouldn't feel comfortable saying something's happening at the respiratory level based on a reading that is local to the muscle itself. For example, looking at the quad and then saying, oh, that means that, it's a little bit like, oh, it's your ear hurts. It's probably your right toe. It feels like a little bit of this to me. So it's just too far apart and it's not linked enough. Today, for when it comes to the respiratory side, because I've gone pretty far into this as well, I would just say that if you feel like your respiratory system is limiting you, so let's say you can look at RPE, so your rating of perceived exertion, how hard something feels out of between 1 and 10. If you rate your breathing always 1 or 2 notches higher than your muscle, because you can actually split those two apart and you can have a respiratory RPE and you can have a muscle RPE, right? For the same effort. And that's typically what I do when I test someone. I ask both at the end of every interval. And if your breathing is always a little bit more strained than your muscle is, there's a good chance that respiratory system needs a bit of work and will help you then express yourself better in general. But typically, the question is, do you feel limited by your respiratory system in training? And if it's a yes or if it's a sometimes, then I would say, okay, let's work on the respiratory system, because we know that running the respiratory system has a cost. The diaphragm is a muscle like every other muscle. The intercostals are muscles like every other muscle, which means they fatigue, which means we can train them and we can make them more endurant. We can make them stronger. And we also know that at high intensities, so if we take a CrossFit effort, typical Metcon, we're going to be at high intensity, somewhere between, say, 3 and 30 minutes to make it simple. And we know that at those intensities, the respiratory system can use up to 20% of your VO2. So a fifth of your oxygen consumption is dedicated fully to running your diaphragm, running your intercostals, and just essentially making you breathe. And the part that is super interesting about the respiratory system is that it is more important to your brain than the rest of your body, at least than the rest of your muscles. Because if you lose a leg, I mean, there's a chance you'll survive. But if you stop breathing, you die, right? So the brain, if your respiratory system is fatiguing, your brain is going to actually pull resources, blood, oxygen, from your legs, from your arms, from the rest of your body, and push it to the diaphragm because it cannot allow the respiratory system to fatigue, just from a survival standpoint.
Yep.
And this is actually called the respiratory metaboreflex. Again, well documented. It's been 30, 40 years that it's been in the literature. And you can quantify, you can measure the difference in oxygen delivery to the legs, depending on whether the respiratory system is fatigued or not. And so this is where I think respiratory training becomes really interesting, because you can make, first of all, you can control your breathing better. You can coordinate your breathing, know when to breathe deeper, know how to slow down your breathing, know how to speed up your breathing. Breathing strategy, I think, is an underutilized part of performance, and is going to become something a lot more mainstream in the years to come. I have a colleague in France, Cyril Ricky, who does physiological testing and monitoring with some of the best cyclists and triathletes in the world. Every single day he's out on the road measuring, quantifying, and he has a study that he's going to publish in the coming weeks on 10 months of respiratory training with a group of elite cyclists that have VO2s around 90, if I'm not mistaken. So it's really, the best of the best. And he's shown some drastic improvements, both in respiratory numbers and performance on the bike, based on the respiratory training that he's put in place with them. So I really think that, if it's going to work for those guys, it's going to work for everybody.
Yeah.
And again, going back to the most simple assessment, if you feel like your breathing is limiting you in training, go train your respiratory system, because it is going to help. So here's a kind of an overview of all of that.
That's amazing. And I think, I want to jump in with an example of myself, because I think that will help bring this to life. And because I played around with a bit of Moxie testing. We have an old episode actually with Luke Hall where we did a bit of an experiment, and there's lots of interesting things that came out of it, which I'm now questioning in the light of the unreliability of the Moxie NIRS system, where essentially I was doing a fair amount of running back then, and I would have said I was respiratorily limited, in that if I did a hard session, it would always be my lungs. It would very rarely be my legs that made me stop. And so in response to that, I would add a lot more aerobic training to work on my respiratory system. When we did the Moxie testing, it was on the assault bike, it was on my quad, and it showed that I had that parabolic curve, in that I could only desaturate to about 50%, and actually vomited afterwards. So I gave it everything.
Yeah.
And there's still 50% oxygen in my blood. So I did a month's training working on desaturation, and just because life was busy, I didn't run as much as I normally did. And my VO2 actually went down in that month, but my performance in the ramp test went up from doing these horrible desaturation intervals where I'd basically do an all-out effort of 30 cals till my legs felt like concrete, and I was, going through treacle. And so I thought that, to me, was good evidence that might have been my limiter, and that was more effective than the training I had been doing previously. But obviously I was probably pushing myself a lot harder in those sessions than I was in my previous training as well. Does anything jump out at you from that story that helps illustrate your points?
Yeah, absolutely. A couple things. First of all, you said, you felt like your breathing was always giving out when you were running.
Yeah.
And so my first recommendation would then have been, okay, so let's train the respiratory system. If you feel like it's lagging behind and you can't fully express what you have in your legs or your heart, let's work on the respiratory system and make it stronger, make it more resilient, build up your competency in terms of coordination and how to use it. And then you'll see that it'll probably unlock a little bit of performance on the running side. Then the second thing you said is I did a bunch of aerobic training for my respiratory system. The funny thing is that the respiratory system doesn't actually get really taxed until you go above the second threshold, so into that third level of intensity, the high intensity. And you can feel that, because at low intensity, you should be able to hold a normal conversation. Medium intensity, it starts to be sustained, right? But it's not hard. It's not hyperventilation. You can still control your breathing, speak in short sentences. But it's really as soon as you go into the hard stuff, that's where your respiratory system gets taxed the most, right? So if you wanted to target your respiratory system, I would actually advocate for high intensity training, but the problem with, let's call it integrated respiratory training, so inside an interval session, for example, is that you not only have you have to essentially carry your whole body through that really hard session in order to tax your respiratory system. Whereas with the respiratory training, which was more of an isolated approach on the diaphragm and the respiratory muscles, you don't have to incur this whole fatigue that you will invariably have with a hard whole body interval session, right? And so I think that makes it also more easy to integrate into training because it's a smaller piece. You don't have to do, kill yourself on a Norwegian 4x4 or God knows what to get your respiratory system to get stronger. You just need to spend a few minutes with the breathe way better and do the exercises and then just follow the protocol. And that just takes a few minutes, and it's really not as hard an effort, nowhere near as what you would do on an interval session. So that's the first two things that jumped out at me when you talked about the running. Then you said you did the assessment on the bike, on the fan bike, and you had that more kind of parabolic profile. And so from that, determined that you were utilization limited and did some sprints. And this is where we can come back into the nuances of fast twitch and slow twitch fibers. So we have those two fiber types in the body, and we can go a level deeper and say there's kind of three main groups typically, and there's that's type 1 fibers, which are slow twitch, and then there's the type 2A and the type 2X, which are fast twitch fibers. Now we know that there's intermediates between those three, so that we could actually say there's 5 different kinds, and the ones that are in the middle can go either way. So there's ones that are kind of type 1/2A. Well, if you do a lot of easy or endurance training, they're going to go towards the type 1. And if you detrain or do a lot of strength training, they're going to go towards the 2A. And then again, there's the hybrid ones that are between the 2A and the 2X. And detraining / very explosive and short training is going to pull them towards the X. And then aerobic is going to pull them towards the 2A. And it seems like from the last things I read on this, it's about, it might be around 50-50, meaning that 50% is predetermined by your genetic package, but the other 50 is highly determined by your training. Right?
Okay.
So you can influence to a fairly high degree what fiber types are going to be expressed in your body based on your training. And again, the more endurance training you do, the more it pulls towards the 1, and then the detraining, aging, and then strength training is going to pull it towards the 2s or towards the high bracket.
Did you say aging brings you towards fast twitch?
Yeah, because essentially anything that doesn't stimulate and develop your slow twitch fibers that are full of mitochondria is going to pull you towards the fast twitch side. So it's not that you become jacked because you do nothing or you age, right? It's just that you detrain those slow twitch fibers, and so your body defaults back to whatever's easiest to maintain, right? The mitochondrial network needs stimulation to function and to grow. And for this, you need to feed it with easy exercise, lots of volume, sunlight, good food, and all the other good things that we know about the world, right? So this is kind of the foundation. And then going back to what we were talking about, so different fiber types. We talked about this before. They have different content of mitochondria, right? So a slow twitch is going to have upwards of 3 times the amount of mitochondria that a fast twitch fiber will have, and the fast twitch have evolved to compensate for that lack of mitochondria by actually being able to use a lot more oxygen in the little mitochondria that they have, right? And there's a paper that came out, I think it's the beginning of this year or the end of last year, called Need for Speed, and it looks at the different mitochondrial content of slow twitch and fast twitch fibers. And if your listeners are interested, I can provide a few of the resources for those who want to go and dig into this. And if we go back to the respiratory chain, the energy electron transport chain inside the mitochondria, complex 5 at the very end is where ATP gets put back together, right? This is where the protons get pumped through, and it's literally like a wheel, right? It's like a wheel that spins, and it takes ADP phosphate, puts it back together into ATP. And it looks like fast twitch fibers have a lot more of that complex 5, which allows them to produce a lot more ATP. And they have there's the cristae, the kind of folds inside the mitochondrial inner membrane. It seems like in fast twitch fibers, essentially they compensate for the lack of mitochondria, but by having them they have a lot more folds inside of them, which essentially gives them more surface area to play with. But fast twitch fibers use oxygen much faster, but are a lot less efficient as well, because they obviously produce a lot of byproducts. Glycolysis is a big part of how they function as well. And so we have to deal with all that byproduct, right? The lactate that's produced won't be able to be fully recycled inside those fast twitches. So what happens? They pass it down to the slow twitches and it gets recycled by your mitochondria over there. And this kind of distinction between slow twitch and fast twitch actually ties in nicely with some other studies that have been available for a while now. It was really nice when I read that Need for Speed paper, because it really kind of put those concepts back together. And the other concept was about the different types of training and their influence on your mitochondria. And typically what I've seen so far is that low intensity tends to grow your mitochondrial network, grows mitochondrial capacity, right? So as you do low intensity training, zone 2 volume, all that stuff, you're going to essentially grow the network of mitochondria, the power grid inside of your cells. It's going to take up more and more space. To give it a rough idea, in sedentary people, I believe the average cellular content of mitochondria is about 3%. And in highly trained cross-country skiers, it could go up upwards of 10%. So you can double to triple how much mitochondria is inside your cells with training. Obviously, genetics plays a part, and the more slow twitch fibers you have, the more potential you have to develop that capacity. But training can have a tremendous effect on your physiology and the makeup of your cells, and more specifically, your mitochondria. So low intensity training builds mitochondrial capacity. And on the other side of the spectrum, very high intensity, so the stuff you were doing on the 30 cals all out, okay, kind of sprint interval training, was known to build what people coined like mitochondrial function. So it increases how much oxygen you use per unit of time, right? Now, we tie that back with another basic concept of training, which is the Henneman principle, the size principle, which tells us what motor unit we recruit based on the power or the force demands. What I mean by that is that muscle fibers are organized in bundles that are attached to a motor unit, right? So the motor neuron, sorry. So the motor unit is the neuron, the axon, and then a bunch of fibers that it's attached to. And when that neuron, that motor neuron fires, all the muscle fibers that are attached to it contract. And if you have to, let's say you're doing a low intensity effort, so you don't have to produce a lot of force, so you don't have to have a very strong neural impulse, right? The electrical signal inside your brain that is necessary to power the work is fairly low, right? So it's good because those slow twitch fibers are typically attached to what we call a small motor unit, and that small motor unit has a low activation threshold. So you need a very light electrical signal in the brain for that one to fire and for those fibers to be recruited. Now, if we go to the far end of the spectrum on the other side, what do we call sprint training? We call it neuromuscular training as well, right? Why? Because we need as much neural activation as possible. And so what muscle fiber or what motor units are going to be activated? The biggest ones, the ones that have the highest activation threshold. And it turns out that those ones, the big ones with the high activation threshold, have a lot of fast twitch fibers attached to them, which makes sense because we don't want to recruit our fast twitch fibers when we're doing something easy. It wouldn't be efficient at all. So we recruit the endurance stuff, the fatigue resistant stuff when we do low intensity. And then when we need to do high intensity, we need to recruit everything. So everything turns on, and that's where the fast twitch fibers are recruited. That's also why I remember a few years back, Rich Froning, I forget if he had a back injury or something, and he couldn't squat with a barbell. He did a lot of sprint training on the bike and said that he was able to maintain most of his strength that he had previously. Obviously, you always lose a little bit, but he was able to maintain most of that through sprinting. So it's not going to be the same movement, but you are going to recruit all of those fast twitch fibers that you would typically recruit in strength training, right? And on top of that, you're going to recruit them with a movement pattern that is much faster right? The heavy squat is a slow movement. Sprinting at 120 RPMs on the bike is a very fast, explosive movement. So you're going to be able to recruit all those fast twitch fibers, stimulate them. And then going back to what we were saying before, since sprint interval training recruits and fatigues fast twitch fibers, what do we say about how they work? They work by using more oxygen because they have less mitochondria, hence improving mitochondrial function. And then on the other side, when you recruit the slow twitch fibers at low intensity, how do they build? They make more capacity. And so now we have both sides of that, understanding that low intensity training builds mitochondrial capacity in the slow twitch fibers, and then sprint interval training builds oxygen utilization, mitochondrial function inside the fast twitch fibers. Again, which matches with that Henneman size principle of how muscle is recruited based on the work that needs to be done.
That's awesome. So I think the first thing I took away from that was that doing those desaturation intervals, I was actually training my respiratory system, and I'd basically conflated aerobic and respiratory, which is not accurate. And to train your respiratory system, you need to be breathing hard, not just breathing. And that's a really useful takeaway, hopefully, for a lot of people. And those desaturation intervals would desaturate the oxygen in the muscle for sure, but also challenge my respiratory system at the same time. So that's another vote for there is one energy system. Basically, like, the hard training of it all.
And those desaturation intervals would target and work on your fast switch fibers primarily, right? And which will help you. Another thing that I picked out of what you said before, is that you improved because you worked really hard. But there's also, and I'm sure you did because those intervals are disgusting. But there's also the idea that the best training is the one you've never done or that you haven't done in a while. So if you just switched up what you were doing from what you were previously doing and you had been doing that other thing for a while, then chances are your potential for improvement was much higher on that new kind of approach, new method, simply because it was new.
Yeah.
Right. Back to that adaptation accommodation idea where it's at the start, you adapt really fast and you make, when we talk about beginner progress, it's actually a thing. It's a thing because anything that you're a beginner in or new in will give you really high returns on your investment, especially at the start. Over time, that decreases. But this would be, I think, one argument for cross training in general. Like, do new stuff, do things you've never done before, explore intensities you haven't explored before, because you are going to improve more than what you're currently doing because you've been doing that forever, right? And so, that I guess would encompass one of my main axioms of training, is that this, when it comes to endurance, that intensity spectrum, low, medium, high, very high intensity, you need it all. And you need to tap into all of those different levels at some point in your training season. Right now, what you do when depends on what you need, depends on your sport, depends on how you're built, right? Are you a slow twitch athlete? Are you a fast twitch athlete? Which type of sport are you in? Is it a long distance sport? Is it a very short and explosive sport? Is it somewhere in the middle? And what time of the season are we at? Are we 2 months out of the competition? Are we 6 months out of the competition? And once you have the context, which is, in my opinion, the most important question that nobody asks when it comes to planning training, it's like, what is the context? Who are you? What do you need? When's your next competition? What phase are we in? What are the demands of your sport? Once you have those, you pretty much, and you understand the basic concepts that we've laid out today. There's 4 different levels of intensity, which are all important because they're going to target different parts of your body and different ways that your body can produce or recycle energy and sustain it. Then you just put it all together and make sure that you sequence your phases of training based on all the context that we gave. And then Bob's your uncle.
Easy as that.
Easy as that.
Why didn't you say it? It's so simple. So I just want to sort of neatly box off the limiting systems model. I think my summary of what we've just said is basically it's very difficult to accurately ascertain the real limiter, whether it's respiratory, cardiovascular, or utilization. So therefore, it's going to be hard to prescribe a training intervention to target it accurately. So, one, can I just check that's an accurate summary? And two, what did you then start thinking was a better framework?
Yeah. So I'll go through the three systems and kind of give you the Cole's notes of how I think about them. For me, the cardiovascular system, the let's focus on the heart. It's not just the heart; it's the pipes that go with it, obviously. But let's take the heart because it is a central part. We know it's the main factor in VO2 max, right? How much cardiac output you can produce. And honestly, to assess that, I won't want to have a PhysioFlow, which is a device that allows you to actually quantify how much blood is pumping through your heart, so you can actually see in milliliters every beat and compare that to top athletes and kind of see where you lie on the spectrum. Because in my estimation, if you don't have a quantified measurement of this, it's very hard to say whether your heart needs more training or not. Obviously, you can compare it to other people your level or people at a slightly higher level, but heart rate is pretty variable, right? It's going to change quite a bit from one person to the next. It's going to vary depending on what mode of training you're using. Are you biking? Are you running? Are you doing echo bike? And so it's going to be tough to quantify and say, oh, this is a little bit behind. We need to train it. The best thing if you want to train your heart is just a lot of volume, varied intensities, and years of training. Like there's no shortcuts. There's no, oh, this protocol increases ventricle size by X, Y, Z. No, it's train a lot, train consistently, don't get hurt, vary your training, don't get burnt out, and then you'll have a bigger heart. That's kind of the Cole's notes of how to build a big heart. And I would say that the heart itself is actually rarely the limiter in and of itself. One example I can give is a CrossFitter, Alex, that I worked with for a full year. We did a full physiological test, and he followed the bike training I gave him for a year, and came back and did another test. And what was really interesting is that in the same conditions, same equipment, same mask, same everything, on the second test, not only did he go 3 stages farther into the test. So the first test, and I used a protocol that is 4 minutes on, 1 minute off, and typically we go up every stage until failure, and typically people do around 10 stages. So I calibrate the test to each person so that they do on average 10 steps. Sometimes it's 9, sometimes it's 11. It doesn't matter. The point is to have enough data to do the interpretation and not need 7 hours to do the test. That's kind of the compromise that we're trying to find. So Alex went up, I think it was he did 125 or 150 at the start, and then he went up by 25s. He finished the set at 325 watts. He's a big guy. He's in the 90 kgs. And that was his initial test. Then we did a year of training. Nothing complicated. We did some pyramidal training for 3 months. Then we did some polarized training for a couple months. Then we did some sprint training for a month. And then we did the same again. And he came back a year later and he did the same test again. And he went up from 325 as the final stage up to 400. So he added 3 full stages to the test. Obviously, his lactate curve changed completely. But most interestingly, and back to the heart conversation, his max heart rate went up from 171 to 188. Wow. And again, I put that on the list. I can send you the graph. So did we increase his max heart rate, or was his heart capable of beating that fast in the first place anyway? And it was just his legs limiting how far we could push his heart. So that, I think that's an important question, and I can't say for sure, but based on my experience and what I've seen so far, I would say that everybody's heart is capable of beating much faster than we see it do in training. And that given the right metabolic demand, so very hard training, a lot of heat, those kind of things, you can probably push your heart way past what you think it can do, right? Now it's, so in that case, when it comes to the heart, it's always going to be the legs that limit the heart, because it is about the metabolic center, which is the muscle itself, right? Yeah. I really see that there's the muscle on one side, which is where oxygen is used and where all the energy systems exist, and then there's the rest of the body, the systemic aspect of the breathing, the heart, the vascular system that feeds the muscle essentially. So you could think about those two separate sides. But the heart for me is, yes, you can make your heart bigger, and that is going to increase your VO2 max and increase your oxygen transport and increase your performance and endurance. but we can't quantify that directly without those really expensive tools. And even then, it's always going to be the muscle that limits the heart in a way, right? The only moment where I've seen the heart limit someone, I don't even know if it's the heart, but it's more just the difficulty of exercise in general, is with beginners, because they're just not used to training, or not used to training hard, to the point where it's not their legs that give out, it's not their breathing that gives out, it's just that they're tired and that it's too much and that they can't push past that, which is typically not the case with people that train regularly, because they can go beyond that. And so now it's going to be something physiological that's going to manifest itself, right? So there's a heart on one side. The muscle for me is always going to be the ultimate limiter when it comes to endurance performance. But obviously the breathing, as we said before, can obviously play a part. And the interesting thing about the respiratory system is that it is tightly coupled to our perception, meaning that your brain reads your breathing, and if you're breathing fast, your brain reads that as it's hard. So by training your respiratory system, learning how to manipulate your breathing, lower your breathing frequency, increase your breathing volume, you can have better control over your mind in training, and make sure that your brain doesn't think that it's panicking because you're hyperventilating and you can't control your breathing. Typically, and people feel that in training, when you lose your breathing, you're close to the end, because typically shortly after, your brain just says, okay, tap out, because you just can't control things anymore. If you can keep your breathing under control, it's going to completely change your frame of mind, and it's going to completely change what you can actually do or think you can do, and then in turn do. So for the breathing, again, I would almost put it aside from the other two in the physiological conversation, because the breathing process itself, the transfer of oxygen from the lungs into the bloodstream, is almost never a limiting factor, unless you're an elite endurance athlete and you're pumping 40 liters a minute through your heart, because you have an enormous heart. And then at that point, the capillaries inside or on the lining of the lungs, the red blood cells go single file inside the capillaries, because it's so small, right? That's what it's called, micro vessels. They're absolutely tiny. And when you increase cardiac output from a few liters a minute at rest to 40 liters a minute for those elite endurance athletes, imagine the speed difference that those red blood cells have to go through the capillaries. And there's actually a condition called arterial hypoxemia that some of these elite athletes have, which means that their arterial blood desaturates, meaning instead of 99, 98% that you would typically see on the thing that you put on your finger, it actually goes down into the low 90s and even dips into the 80s, because their red blood cells are moving so fast through their pulmonary capillaries that oxygen doesn't have time to jump in, right? It's like the cabs are going so fast that the passengers can't even get in. But apart from that situation, and apart from obviously environments, for example, altitude, where you have a reduced partial pressure of oxygen, which makes everything harder for the body, except for those kind of edge cases, the breathing in and of itself is not a limiting factor in the oxygen transport. Which doesn't mean that you can't train your muscles, respiratory muscles, and then make your performance better in general. So that's why I would kind of put the respiratory system a little bit on the side when talking about those limiters. And then when it comes to the muscle, well, you need it all. You need the slow twitch for the long, easy efforts. You need the fast twitch for the short, powerful efforts. You need the slow twitch to recycle all the stuff that the fast twitch produces in those hard efforts. So again, everything works together. You need it all, and you need to explore those different levels of intensity throughout the year intelligently, so that your body is fully conditioned and ready to do whatever you require it to do in your sport, whether it's CrossFit, whether it's high rocks, whether it's a marathon.
Awesome. Yeah, I think everything seems to be hinting in the direction that is my default assumption for any training decisions, and it's basically specificity of what are you training towards. Train in a way that replicates it in a progressively overloaded manner, and the physiological systems will do what needs to be done to enable you to do that.
I think you can actually think in two stages, and then there's obviously shades of gray in between, but there's two main stages. There's what is the type of training that's going to help me perform in my sport. So if you think about CrossFit and you think about the monostructural work, it's going to typically be pretty short, high intensity intervals because this is where the sport is. Yeah, sure. Sometimes I do a marathon, but in the 99% of cases, the Metcon is going to be between 3 and 15 or 3 and 20 minutes. So this is high intensity, right? Based on what we know of how the body operates. And so you're going to benefit from doing that type of training, especially if you're close to a competition. But then there's the second question, which is what training helps you train better?
Mm.
And sure, you need the high intensity intervals to get better at CrossFit proper, but you need the low and the medium intensity to do more high intensity, right? So that's where I like to introduce. You talked about specificity, and then there's the kind of the flip side of the coin, which is the specific training, and there's the general training. And this is where GPP, general physical preparation, I think has we've uh, we've lost the plot a little bit, because we say, yeah, I need to train for this, and I need specificity because specificity makes things work. So I just need to replicate my sport and just do that, and that's all you do, and you end up with fairly good athletes that are ultra specialized but have no foundation when it comes to their physical preparation. And this is where reintroducing, again, at the right time in the season, you're not going to do a phase of low intensity training a week before your CrossFit competition. This is not the time or the place, but you need a general phase, typically away from competitions or at the beginning of your season, to establish a foundation of fitness, conditioning, strength in general, independent of what you're going to be training for later, that will then help you train better in your sport, right? So you have the training that makes you better for your competition, and then there's the training that makes you better in your training. And you have to think in those different stages. And I think you can get very far with specific training only.
Mm.
But once you get to the limit of what you can do with only training your sport and only doing the things your sport requires you to do, then you need to shift gears because you're literally revving up into the red zone at the, you're in second gear and you're revving up your engine to the max. Well, it's time to go to third, drop the RPMs a little bit, and then start working a little bit differently. And this is, I think, where having more distinct phases in your training year becomes very important, because when you're a beginner, everything works, right? So you can do CrossFit balls to the wall for 3, 4, 5 years nonstop. You're going to see progress. But when you stop seeing progress, the answer is not more of the same and harder, because you've already done that. Now the answer is, what have you not done for the last 5 years? Right? You haven't gone for a jog. You haven't done medium intensity sustained training. You haven't done any of those stuff because it wasn't part of CrossFit. But again, what's the best training you can do? It's the one you've never done, or the one you haven't done in 5 years. And so go back to those things when you need it at the beginning of the season, build a foundation, and then go back to your CrossFit after. And essentially bouncing back and forth between those two main phases, general and specific, obviously tailored to your competition season, your calendar, and your needs, will allow you to, again, tap in, tick all those boxes throughout the year and make sure that you're not deficient in any of those areas. Because if you are, you will see it in training.
That's a really good explanation. I think, yeah, one of the things we talk about with specificity is that there will be a point where you no longer achieve the desired training stimulus because you've pushed that button too hard too many times. Like if you're training 1 rep max snatches, you can only do so many before it's not actually improving your snatch because there's a breakdown in something other than your snatch technique. So you have to come away from the highest level of specificity to lay a better foundation to then go back up again later. Mm-hmm. So it's really cool to see that applied to fitness and conditioning in general. So let me make another pit stop summary of, we've gone through those limiting systems models, and you've spoken a lot about the muscle fibers already. But in light of the journey we've taken the listeners on so far, what is your current view of how we should be viewing conditioning with regards to physiology?
for me, the basis of all my thinking around endurance is the intensity spectrum with those 4 different levels. And so if we dig into this just a little bit more, I talked about the low intensity, medium intensity, high intensity, and very high intensity. So let's get a bit more detailed on this, because that's the foundation of everything. Based on this, if you understand the spectrum, then you can reason coherently regarding the energy systems that we talked about at the beginning. And you can see how they interact in those different levels. And then you can go a step up from that intensity spectrum and think about training, and think about zones, and think about actually creating the training sessions that will help you build those different qualities, right? So if we break down that spectrum just a little bit more, I gave this kind of the simple names: low, medium, high, very high intensity. If you read the physiology literature, you're going to find those called domains. There's 4 intensity domains, and the low intensity is called the moderate domain. The medium intensity is called the heavy domain. The high intensity is called the severe domain, and then the very high intensity is called the extreme domain. Now, one of the most important parts of physiological testing is to essentially parse out those domains and figure out, okay, for me on the bike, I know that the transition between low and medium intensity is around 140 watts. And the transition between the medium and the high intensity is around 230 watts, right? So we would say that my first threshold transition from low to medium is around 140 watts. And my second threshold is a transition between the medium and the high intensity around 230 watts. So that would be on the physiology side. Now, to quickly address what we call the extreme domain, or the very high intensity, there's no real tests that are useful to find it, and it doesn't. There's no practical implications to knowing that exactly where it is on the spectrum for you. All I would say is that it's typically around 2 minutes of hard effort, right? So around that, you switch from typically high intensity to very high intensity. And for those who like the details, the difference between the two is going to be in whether or not you reach VO2 max. So typically, VO2 max is not a power, it's not a speed, it's something that you reach when you spend enough time at high intensity, right? Because we go back to those 4 levels. When we're at low intensity, we could conceptualize that as a balance or a steady state inside the muscle itself. Going back to the energy systems, we know that at low intensity, you produce very little lactate. And lactate is not the cause of fatigue, but lactate comes with a bunch of other things that cause fatigue: inorganic phosphates, hydrogen ions, and those things, right? So when I say lactate, it's just a good surrogate for the fatigue metabolites. It's not the cause of fatigue itself. Lactate is a half sugar. Your body uses it inside the mitochondria, right? It's fuel. It's not fatigue. But we know that at low intensity, you produce very little lactate, and you can recycle all of it inside the cell, right? Inside the mitochondria itself. Hence the balance at the muscular level. You're not offsetting any of those metabolites inside the blood, because you can internally manage that load. So low intensity is a steady state at the muscular level, or at the local level, right? So your quad is doing the work when you're running or cycling, and nothing's getting out into the blood because everything can be recycled internally. That's low intensity. Now we go up a level to medium intensity. And what did we say about the lactate and everything that happens inside the cell? We said that the mitochondria is now saturated, right? It's dealing with as much lactate and stuff as it can, but it can't do any more than that. So what is it going to do? It's going to pass the excess onto the blood and the rest of the body. So now we have a steady state, but at the systemic level, at the global level of the body, right? So low intensity, local equilibrium or balance or homeostasis, medium intensity, systemic balance. And then once we go beyond what we call the second threshold, so for me, when I go from 200 watts to 260 watts, for example, I go beyond that second threshold, I go into high intensity, and now I can no longer maintain that internal balance. I can't bring enough oxygen to deal with all the stuff that's going on. That's essentially how you can conceptualize the second threshold. It's the maximum oxygen you can deliver to your muscles. And just because essentially the tap is open as much as you can, right? But the tub is still emptying, even though you've maxed out the tap essentially. And so what happens is you keep using more and more oxygen, because why? We're recruiting more and more fibers. We're trying to produce more and more power. On top of this, the fast twitch fibers, they fatigue. And so when they fatigue, you have to go recruit other ones to do the job that the other ones didn't do. It kind of that runaway effect. And where I was getting with this is that now you're at high intensity, you can no longer maintain that balance inside, right?
Yeah.
And that's physiologically, that's the best way to tie together the energy systems that we talked about before, the functioning of the body as a whole, and then those different levels of intensity. And to conclude on what I was saying before, when you're at high intensity, so when I'm above that second threshold, but when I'm below about that 2-minute max effort, this is where VO2 max is going to manifest itself. Now, if I go into a short effort, like something I can only hold for a minute, I'm not even going to have time to reach my VO2 max, right? Because you reach, essentially, you fatigue locally before you even reach your maximal oxygen consumption. And this is the distinction between high and very high intensity. This is where the difference lies between the two. So it's interesting to know it on the theoretical level, but concretely speaking, it's not interesting to measure it, right? So for me, there's really threshold 1, threshold 2, which break apart the first 3 domains of intensity, and then your max speed or your max power at the very, very top, which then gives you your whole intensity spectrum and everything that you have to know. And then based on that, that's the basic model. And then now we can start using zones, right? Jem, my colleague, says that domains are descriptive, meaning that those intensity domains that I gave you describe what is going on internally, right? So if we think of lactate, low intensity, we have very low lactate levels and they stay steady. Medium intensity, you have raised lactate levels, and it's gonna be raised, but it's gonna be stable in time. High intensity is gonna keep going up and up and up until you have to stop. And then very high intensity on the lactate side is the same as the high intensity, just faster, right? Because you are using even more fast twitch fibers and you are fatiguing even faster. So we can describe what's happening with the physiology through the lens of those intensity domains or those 4 levels. Now the zones, they're prescriptive, meaning that we use them to prescribe training. And essentially what we're going to do is take those 4 levels and break them up into smaller pieces to help our tiny little human brains understand what we're trying to achieve, right? And so once we start applying the zone model to the intensity spectrum, because again, a zone is not a heart rate, right? That's a huge mistake that I see in the endurance world, is that we take our max heart rate, whether it's calculated or measured, doesn't matter. And then we take, okay, 70%, that's my zone 2. Well, 70% is correct for the average population, but you're not the average. And you could be somewhere between 55% of heart rate max all the way to 80% of heart rate max at your first threshold. And that's going to change with training and with time as well, right? So we can't just take a fixed number, and we have to consider that there's a lot of variation in a given population. And then so based on those 4 levels, we can start to talk about zones. So typically zone 1 and zone 2 are at low intensity. Zone 1, we typically say, is active recovery. Zone 2 is base endurance. So zone 2 would be, if we had to give numbers, I would say between maybe 70 and 100% of your first threshold. So for me, my first threshold is at 140 watts on the bike. So my zone 2 would be, I don't know, 100 to 140, let's say. Okay. And if I'm below that, I'm at an active recovery. And if I'm between 100 and 140, I'm in my zone 2. But there's no physiological distinction between zone 1 and zone 2. That's just an arbitrary number or an arbitrary boundary that I gave because we split up zone 1 and zone 2, right?
And I just want to double reiterate that that's what's not beats per minute, just because watts. Those numbers might confuse people.
Exactly. So the watts are on the bike, and obviously there's going to be a heart rate associated with that power output. So for me, at 140 watts, I might be at, I don't know, 115, 120 beats. So that's my zone 2 heart rate. But it's based first on the threshold concept, which is at 140 watts. And then secondarily, I measured my heart rate at that intensity. I didn't do math on my heart rate to figure out my zone 2. right? Because it's the power that's going to determine what's going on inside. It's not
Yeah.
the heart rate. Because on a good day, I might be 5 beats lower. On a bad day, or if I'm sick, I might be 5 or 10 beats higher. If it's very hot outside, I might be 10, 15 beats higher.
Definitely.
All those things can influence heart rate, right?
That's so important. I think I just want everyone to take a pause to sort of soak that one in, because we obsess with our heart rates, and I've been guilty of this myself. But that's so immaterial in the grand scheme of things. We care about our performance and our output, so we should measure everything based on our output, which is watts.
I think that there's the and I'll come back to the zones, but I think a good little aside here is Steven Seiler's 3 Ps: performance, physiology, and perception. So ideally, you want to have that 3-pronged approach to quantifying any type of endurance effort. So obviously, first you have what we call the external load. So the power, the output, the power that you're producing, the speed that you're running at, that's your external load, and that's a performance metric, right? You always want to couple that with the perception side of things. So how you feel, right? And I'm the first to love data and science and all that stuff. RPE is extremely well established in the literature. I actually have a mini course about it. I'll send it to you so you can check it out. But it's very well researched. It has been for decades, and it's probably the most useful metric that you can have in training. Learn to listen to yourself. And it's a skill like every other skill. So if you've never listened to yourself, you can't just throw your hands up in the air and say, I don't know how to listen to myself, so I won't do it. No, it's just that you've never done it. But start doing it, put in the reps, ask yourself, how does it feel? How does it feel? How hard is it? How hard is it? And the more you do it, the more precise you get. And so that's the perception side. You have the external load, the performance metric, whether it's watts on a bike, kilometers per hour, or miles per kilometer, or minutes per kilometer in running. And then you have the perception side of things. The easiest is use the 1 to 10 scale. So how is it? And obviously, it's going to depend on the type of effort you're doing. Meaning that you can do a 3-day long hike, and it could be a 10 out of 10 if it's really hard, right? But you could also do a 2-second sprint, and it feels like it's maybe a 2 or 3 in terms of difficulty. It's 100% effort, but it's easy in terms of fatigue and difficulty, right? So it's always contextual to the time that you're using it on. That's important to consider. And that would be part of the internal load, right? We have the external load with the output, and the internal load is the perception and the physiology. So if you have heart rate or if you have lactate, those are all good metrics to also use. But you have to base the foundation of your thinking around the performance metric, the external load, and then your perception. And then you layer in the physiology with the heart rate or the lactate, right? So I'm not saying that heart rate isn't useful. Heart rate is extremely useful, but you have to know how to contextualize it based on what we talked about before, right? You can't just take a number out of the air and say, oh, that's my zone X because my watch told me so. Yeah, your watch takes your estimated or calculated max heart rate, and then it applies those basic percentages that are true on a population level, but that are wrong for almost every person individually, and says these are your zones. And they don't make the difference between the bike and then the run, because your heart rate is going to be different on the run than it is on the bike, right? Some people could have high heart rate on the bike compared to the run if they bike a lot but never run, right? So always contextualize the heart rate, but found your thinking around the external load, the performance metric, and your perception internal metric first, and then you layer in the heart rate. Okay, so that's the 3 Ps: performance, perception, physiology from Steven Seiler. That is a very useful model to quantify any type of effort.
Awesome.
And what I'll do just after I give you the zones is I'll give some RPEs, some difficulty levels that can be associated with each zone. So it helps us actually approach endurance in a very, very simple way and just learn how to listen to your body and know where you are. Because sure, we could do a lactate test, we could do a VO2 test, we could do all that complicated stuff, but you can also just pay attention to how your body feels and have a really good rough understanding of what is low intensity for you, what is medium intensity for what is high intensity for you. And you could do that over less than 30 minutes, right? And I can give that to you at the end if you want. So we had zone 1 and zone 2, which were on the low intensity side of things. Now, zone 3 and 4 typically are going to be over the medium intensity. Okay. Now, zone 4 is typically considered the threshold, right? That's what we call it. And it talks about the second threshold, right? We had that first threshold that's at the top of low intensity. And on the zone model, it's going to be between zone 2 and zone 3. And then we're going to have the second threshold that's between the medium and the high intensity. And now it's zone 4 that's almost kind of straddling a little bit those two domains. Because those thresholds, I gave you 140, 230 for me on the bike. They're not to the watt, right? They're more like phase transitions. So again, thresholds are wrong, but they're useful as a model to understand the intensity spectrum. And they're also going to change with fatigue, right? For me, it's 230 when I'm fresh. Make me cycle for 2 hours and then test my thresholds again. It's no longer 230. It's maybe 200, right? And that's actually one of the features of highly trained endurance athletes is their durability or their resistance to fatigue. So their second threshold is at, 370 watts when they're fresh, and it's 360 watts after 4 hours of cycling, right? Whereas for most people, it would drop by 10% or more. And this is one of the performance factors in long duration endurance sports, right? So we have that zone 3, zone 4 that are kind of over that medium intensity. And the way I like to frame it is that zone 3 is closer to the first threshold. So the intervals will be longer because they're less intense, whereas zone 4 is closer to the second threshold. So intervals will be a little bit shorter, right? But physiologically speaking, there's no difference between zone 3 and zone 4. You can't measure a difference in lactate. Oh, sure, the lactate is going to be a little bit higher when you're in zone 4 than it is in zone 3, but it's still going to stay stable over time. And this is why the Norwegians use lactate as one of their main means of monitoring training. It's because they do, especially in the endurance sports, they do a lot of tempo, zone 3, threshold, zone 4 sessions, which both have the feature of what? Of a stable internal state, right? So you're going to see maybe 2.5 millimoles on your tempo sessions, but that's going to stay stable across the session. And you might see 3.5 to 4.5 millimoles on your threshold sessions, but that's going to stay from interval to interval again. So that medium intensity can be easily monitored using something like lactate. The difficulty with heart rate there is that you're invariably going to have a heart rate drift as soon as you go beyond the low intensity, which should, if you're in zone 2, an easy way to see if you're in zone 2 or not is if your heart rate stays nice and flat. Right? Can you do an hour with your heart rate not moving? If it starts moving up after 10 minutes, you're going too hard, or you're just not used to that effort yet, and you need to maybe work it in smaller chunks, or you need to even slow down so that you keep a stable heart rate, right? But as soon as you go into medium intensity or above, your body's going to progressively fatigue because we're recruiting more fast twitch fibers, which are less efficient, and then this whole cycle continues, and you're going to see that heart rate drift from interval to interval. And obviously, the more you train, the less drift you're going to have, but you're still going to have drift. So you can't say, I'm staying exactly at, let's say somebody says, my zone 3 is between 70 and 80% of my heart rate max. So my zone 3 is between 120 and 140 beats, right? But if you start at 140 beats on your first interval, it's going to be 143, 145, 147 on the next intervals. So that's, again, contextualizing the heart rate to help us understand what is going on is super important. Right. So we have that zone 3, zone 4. Do you want to?
Yeah, can I jump in?
Sure.
Could you just give a couple of example sessions to bring that to life for people?
Yeah, man.
Something that
let me finish the zones, and then I'll come back through and give RPE for each zone, and then 2 or 3 examples.
Perfect. Thank you.
Yeah. So zone 5, high intensity. Right. That's simple. It's just the high intensity above second threshold up to, like we said, about 2-3 minutes of effort, right? That's going to be considered high intensity or zone 5. And then beyond that, so that's the typical 5-zone model that you find on the watches and with heart rate and stuff like that. But we didn't touch the very high intensity, right? The extreme domain. And that really, how you break that up into zones really depends on what you're trying to do with your training. I give you a concrete example. If you're training for a marathon, you're going to spend very little time at very high intensity. Maybe you're just going to do some speed work right at the beginning of your training phase, because it's important to coordinate that. It can improve economy. There's many benefits to learn how to run fast properly. But you're not going to be doing sprint interval training running. You're not going to be doing, really hard 400 or 200 repeats. So typically when you do long endurance work, you don't even talk about what's happening beyond zone 5. Now, another example would be my friend Vincent, who used to compete in indoor rowing on the 500-meter discipline. So sprint, that's going to take him a minute and 17 seconds, I think, was kind of his time. Obviously, he's going to spend a lot of time in that very high intensity domain with different types of training, some short intervals, some longer intervals. So he uses 9 zones, meaning there's the classic 5 that we went over, which cover the low, medium, high intensity. But then his very high intensity is broken up into 4 chunks. Wow. Based on the type of training that he's going to be doing. Right? I like to break it up into 2. So I've got a zone 6 and a zone 7 for, again, most people, most contexts, where zone 7 is the very high end. So short sprints, I would call it. And then zone 6 would be long sprints. And typically long sprints hurt more than short sprints, right? So we could kind of break those apart like that. So now that we've gone over the whole thing, if it's cool with you, I'll go back to the beginning and then add RPE and give an example.
Right? Please.
So zone 1, we'll go back all the way to the beginning. RPE 1, very, very easy effort. The easiest you can do, right? Typically, zone 1 isn't a huge part of somebody's training volume, right? It's going to be for people, I would say that zone 1 would be more for people that already train a lot and almost need to maintain a high volume of training, and taking a full day off might be counterproductive for them. And so in that case, introducing some active recovery, but it's typically going to be pretty short, 20 to 40 minutes typically. And again, 1 out of 10, and it could be a 20-minute easy bike ride. It could be a 20-minute jog, really easy jog if you're already competent in running in general. It could just be something where you do 5-10 minutes on the bike, then you get off and you do a bit of mobility or different activations, a little bit of core work, get back on the bike and do something like that. It's something, but again, really easy. 1 out of 10 should be the highest it goes in terms of difficulty. Okay. Now we go to zone 2. Zone 2, I would typically give between 2 and 3 out of 10 in terms of difficulty. Obviously, if you train for cycling event and you're doing 4 or 5 hour rides, it can go higher than 2 or 3. But in that context, the duration of the session makes the difficulty of the session. As in, I would count that session as one of the hard sessions of the week, right? I wouldn't just do a 4-hour ride and say, but it's low intensity, so it's easy. No, it's going to take you a couple days to recover, especially if you're not used to it, right? But typically for that low intensity, it could go anywhere from 20 to 30 minutes at that 2 to 3 RPE. So for me, like I said, based on my numbers, I would sit around 120 watts, typically a little bit below my first threshold. There's no point in being on top of it. Just give yourself some margin, which just means you're going to be able to do more. And more is the name of the game when we're below the second threshold. And we'll come back to that with zone 3 and zone 4. Oftentimes we do those sessions and we want to make them harder to progress. No, just make them longer. Because if you go harder, soon enough, you're going to go above that second threshold. Now we're not doing the same kind of work anymore. So think about extensifying sessions when you're below the second threshold. So again, zone 2 could be 20 minutes for somebody's beginning, could be 40 minutes, could be an hour, could be multiple hours if you're training in an endurance sport, or you're in a phase where you need to develop that base endurance to a high degree. Then we go to zone 3. And zone 3, zone 4 is where we're going to typically start to see intervals come in, right? And what I would use typically for intervals in terms of work to rest ratios would be 3-to-1 or 4-to-1. I think that's the easiest way to think about and structure zone 3 and zone 4 training. Typically, zone 3, I would say RPE 4 to 5, maybe bordering onto 6 when it's a really big session towards the end of a progression, for example. I'll give some examples just after. And then zone 4 is going to be more in the 6 to 7 range. So again, it's a sustained effort. 7 is not easy, but you're still in control and it's still sustainable, right? That's the most important thing to remember. And if you have a good experience in training and if you can listen to yourself, you'll know when you go from medium intensity to high intensity. You'll know when you go from something that's hard but sustained, and then something that goes into, oh, okay, we've really gone up a notch and I'm not going to last very long here, right?
Mm-hmm.
That is the transition of that second threshold. Now, when it comes to the formats, I like to use a very simple framework for those zone 3 and zone 4 sessions. And since we're on that 4 units of work for 1 unit of rest, you could do, for example, 2 to 3 times 8 minutes on, 2 minutes off at an RPE of 5. That's a very basic zone 3 sessions to start with, right? So think of the total work that you did. It's going to be between 16 and 24 minutes. But we did that 2 to 3 intervals, 8 minutes in zone 3, and then 2 minutes either passive rest or active rest in zone 2, depending on what you're doing. If you're cycling, it's easy to just drop the resistance and then spin in zone 2 for a couple minutes and then get back into your next interval. If you're running, you might want to just stop and walk at the beginning. And then as you progress, you can actually use active recovery in between those 8 minutes to increase the load of the session a little bit. Because obviously it's going to be a little bit harder if you keep running for those 2 minutes, even if you run more slowly, right? And typically, I would say that when we compare cycling sessions and biking and running sessions, I would typically prescribe a bit more volume off the bat on the bike. With the run, I would be a bit more on the conservative side. So for three times 8 minutes that I would put on the bike, I might do 2 times 6 minutes with 1:30 rest on the run for the same level person, for example. And then you can progress that all the way to 3 times 20 minutes over time, for example, on the bike, and all the way up to 3 times 12, 3 times 15 on the run. Again, because the run has that structural load component that you have to be able to tolerate. And that would be one of the big distinctions I make between planning on the bike and planning on the run. The run, I would always respect the intensity on the progressive standpoint, meaning I would start with low intensity. I would go towards zone 3. I would go towards zone 4. I would go towards zone 5. And then I would go into the even faster stuff. On the bike, you can take somebody new and get them to sprint on the bike within a few training sessions. Maybe even the first training session, you could say, okay, drop the resistance, spin your legs as fast as you can. Boom, you have a sprint, very little risk, no problem. But you don't get a beginner that's never run to go and do 30-meter sprints, right? That's a recipe for disaster. So yeah. I think progressing the intensity very diligently and conservatively with the run is super important if you want to avoid injuries. Okay.
Yeah. One question on the run. Sorry to interrupt, Sean. On the bike, it's obviously easy to prescribe watts. How are you prescribing intensity on the run? Are you doing 6 minutes at a speed, or are you doing
good question
distance?
If you've done some kind of test to figure out what is low, what is medium, what is high intensity for you on the run, then you would use that. Otherwise, I would just go by feel, and I would stick with 4 to 5 out of 10. So concretely, what does that mean? You're going to start to feel a bit of tingling in the legs. Your breathing is going to start to feel a little bit heavier, but you can still make sentences, right? And then the distinction when we go up to zone 4 is that your legs are going to burn more clearly, okay? It's like going, if you have, let's say you have 5 levels of burning. Level 1 would be low intensity, so you're not feeling any discomfort in the legs. And then 2 flames would be zone 3. 3 to 4 flames would be zone 4, and then 4 to 5 flames would be zone 5. So that's how I would think about it in terms of the burning sensation. So when we go up to zone 4, it's going to go up a notch in terms of the burning. It's going to go up a notch in terms of how difficult it is to breathe, but again, it's still going to be manageable. And here, what we can do is simply cut the intervals a little bit shorter than what we did in zone 3, because again, physiologically speaking, zone 3, zone 4 is the same effect on the body. It's just that one is a bit more intense than the other, right? So for the threshold sessions, I might start with 6 minutes on the bike, but only 4 minutes on the run. So you could do a 3 times 6 with 1 minute 30 rest on the bike, and you could do 3 times 4 with 1 minute rest on the run. That would be a good starting point, and then we can progress that up towards a good session for somebody who's trained a while. On the bike, we might go to 4 times 8, 4 times 10 minutes, right? So that's going to be an RP of 7. For me, Threshold 2 is at 240. So I would probably do those sessions around 220. 220, 225. Again, keeping a little bit of a margin because I'd rather do more intervals than just go a little bit too fast and then dip into the high intensity. And just to be clear, nothing bad's going to happen if you go a little bit too high, right? It's just about, okay, we're trying to accumulate a certain amount of work in a certain intensity domain. And then we're going to try and do that over multiple weeks. And then it's the total amount of work that you do that's going to be productive, right? And that is what you have to aim for, is consistency and total volume that you build up, rather than just one crazy session that's going to, because you saw it on Instagram and you wanted to do what the champs do, right? It's the consistency over time that everybody overlooks, but that's the real driver of results. And so again, on the RPE, probably 6 to 7 on those sessions. So to give a very concrete example, if we're programming on the bike and I'm starting a phase where I did maybe 3-4 weeks of tempo sessions. So I did a 3x8, and then I did a 3x10, and then I did a 2x12, and then I did a 2x12 plus 1x8, something like that. Just building up slowly, and I kept the same intensity, right? So, but the RPE went from 4 to 5 over those sessions because it got a little bit longer, got a little bit, more difficult. And then once I did that for 3 to 4 weeks, now I can bump it up to threshold, right? I'm still in that medium intensity bracket. I'm just moving from the bottom. I built the foundation. Now I can go and do my threshold better. And so now I might just, again, pull the duration of those intervals back again and start with a 2 or 3x6 if I'm on the bike. And then I would go to 2 to 3x8. And then I might go to, I don't know, I could do a 10, 8, 6, 4. Right? You could do whatever you want in terms of the format, but it's always asking yourself, what are you trying to achieve with that session? What's the target intensity? And in that case, we're trying to build time just under the second threshold, because we're going to obviously help the slow and the fast twitch fibers in terms of sustaining effort. We're going to help build all those transporters that help reuse all the metabolites from the fast twitch to the slow twitch fibers. And that's especially important for all the high intensity sports like CrossFit, like team sports, because you need to be able to go hard and you need to be able to recover. Yeah. And if you only have the fast twitch side or the high intensity side that's been developed, you're lacking the tank on the back end to help you recycle all the stuff that you're producing. And if you can recycle better, guess what? You can go harder, you can go longer, and you can be ready again sooner for your next effort. So that's where medium intensity, which is not specific to CrossFit, if we keep that example, is very useful from a physiological standpoint for high intensity efforts, because it will allow you to do more and recover faster from it, right? If we think of that tap, and once you get to that second threshold, you've fully opened the tap and you've maxed it out. Well, by doing those tempo and threshold sessions, we're going to make the tap even bigger and be able to have more of that oxygen that comes in and better delivery, so that we can sustain those higher intensity efforts.
Does
that make sense?
Yeah, makes total sense. One question on the interval duration. Given the goal is to be sustainable, is it harder to know that it's sustainable if you're doing a 10-8-6-4, because the shorter duration is going to trick you into pushing harder? But is that okay?
Don't get tricked.
Okay.
Stick with and that's why I kind of put it at the end of the progression. I would do the other ones first, and I would stick with the same intensity. I wouldn't start playing with the intensity on those. I would stick with the same, right? Okay. You could do it the other way. You could do a 4, 6, 8, 10 as well. And that's now the coach that comes into play and decides, okay, what am I trying to achieve? Who's my athlete? Does he or her do better with that format or that progression? Is it better to go from longer to shorter, or from shorter to longer? And again, that those are all levers that you can play with based on what you're trying to do with the session. Okay. Right? Before I go into the high intensity, to give a bit of extra context, we can play with those durations and those rest intervals to a quite large extent. Meaning, for example, if you take a pretty famous session, is this 25 by 400 on 30 seconds or a 1 minute rest, which is the Norwegian threshold, right? And so if we think of
Ingebrigtsen loves that, doesn't he?
Exactly. So if we think of the context of that session, so you're running 400s, which you're going to run pretty fast, but then it's called threshold. So what's the deal? And what's interesting with that session, it really illustrates how you can be in two different domains at the same time. What I mean by that is that from a speed standpoint, mechanically speaking, from an output standpoint, you're running at high intensity. You're running above your second physiological threshold, right? So I could do those on the bike, and you could convert them into time. So it could be like a minute 30 on and 30 seconds off. And I could do that 15 times, and that would be a good Norwegian threshold session, right? And if we go back to my numbers, so what did we say, 230 on the second threshold, but I would do those at maybe 250 or 260, right? So mechanically speaking, I'm above my second threshold. But because the intervals are pretty short and we're sticking with that 4-to-1 or 3-to-1 work to rest ratio, if I measured my lactate throughout the session, it would stay nice and stable. So from an output standpoint, from an external load standpoint, I'm at high intensity on paper. But from an internal load standpoint, I'm at medium intensity. So that would be a fantastic session when you're progressing somebody up with running, for example, and they've done the low intensity, they've done the tempo, they've done the threshold, and you want to move them into the high intensity bucket, but they're not quite ready to run fast for long periods of time. So we can move them in that middle ground of that Norwegian threshold, which is faster in terms of running speed than if you did just a basic threshold session, but it stays manageable from a metabolic standpoint, from an internal standpoint, right? And you can play to an infinite degree with those work rest ratios and those durations, but you also always have to be clear on what the goal of that session is, right? And obviously for the Norwegians that run, the 1500, the 3K and all those things, well, they're going to be running fast during those races. So having sessions that are metabolically controlled, that medium intensity, but where you run faster than if you were just running straight 8 or 10 minutes is interesting for them because it's more time spent at a faster speed.
Yeah.
While not costing the body too much because we're still at medium intensity. We're not at high intensity. And you can also do more volume, right? You couldn't, most people, let all other things being equal, you wouldn't do 25 400s at high intensity. Yeah, but Zatopek did. Yeah, sure. But the point is, most people, 99% of people, wouldn't do that amount of volume at high intensity just because your body's going to give out before you get to the end of those. But you can do it if you control that intensity a little bit better and you're actually staying at medium intensity on the systemic side. Does that make sense?
Yeah, makes sense. That's a really nice way of explaining it. Because I think I actually saw there's a YouTube video where Ingebrigtsen gives his training schedule and the times he's hitting for those 25 400s. I don't want to get it wrong, but I've got a feeling it's 50 something seconds. And he does it again and again and again and again and again. So it is sustainable for him. But I think it's a hard mental shift to think, oh, you're doing fast 400s, but it's sustainable because to other people, a lot of people do 400s, they do them in a way that is unsustainable, and that completely changes the stimulus. So I think that's an important point to really keep reiterating that as long as it's sustainable, then you can say it's zone 3 and 4 on the receiving end.
Exactly. So the easiest thing to do is when you're doing your 400 repeats is you ask yourself the question, after the first rep, what's the difficulty? What are you at? And obviously it's going to take 2 or 3 reps to get in the mix properly, right? But starting on rep 3, 4, are you at a 6 out of 10? Or are you already at an 8 or 9 out of 10? If you're already on an 8 or 9 side, guess what? It's not sustainable. You're going to have to stop in 5 reps because you've gone too fast, too soon. If you're at 6, well, that's perfect. Keep the same speed, build volume. You're going to probably get up to 7 towards the end of your session because it's getting longer and it's getting harder. But you still have a very high quality threshold session while running at a faster speed, right? So now that we've kind of touched on that bottom end, and like I said, the main idea to keep in mind with those low and medium intensity sessions is build progression through volume, make them longer, add a set, make the sets longer, but don't try to push intensity too soon, right? It'll come by itself if you do things properly, right? Because if I train consistently and I do my 3 to 4 endurance sessions a week, and I do 1 to 2 sustained sessions out of those 4, and I do some tempo and some threshold, after 6 weeks, 8 weeks, 12 weeks, numbers have gone up, 10 watts, 20 watts. And so naturally my 220 that I was using for my threshold session before is going to become 230, 240. But we've pushed it from the bottom up instead of just forcing it through pushing the intensity too early, right? And so now we can go up into that high intensity, right? Zone 5. And there again, we can find different formats, different work to rest ratios. But typically, you're going to see a big departure from that 3 to 4 units of work for 1 unit of rest that we had at medium intensity. And we're going to go 1 to 1 or 2 to 1. So 30-30s are a very standard high intensity session. I'd say it's a very good introduction to high intensity training. So 30 seconds on, 30 seconds off. Do that 8 to 10 times, maybe do that whole set twice. That would already be a very good session to start. It won't be super, super hard because 30 seconds on, 30 seconds off. So of course, you can do it all out and it's going to kill you. But if you're doing it in a sustained way, sticking with an 8 out of 10 to start, that's typically where I would start progression for some high intensity sessions. I wouldn't start at 10 out of 10 off the bat because I want to build volume over weeks. I don't want just one really hard session and then you're done and then you've already reached your ceiling and you have nowhere to go, right? I want to start at 8, build volume, build intensity, and then build sessions over time. So 30-30, 10 reps, maybe 1 block or 2 blocks, depending on where you're starting from, RPE 8. That would be a good intro session. And we can build that over time, right? We had 2 by 8, then we go to 2 by 10, then we go to 3 by 6, 3 by 8, 3 by 10. And we're already getting to some pretty solid, 3 times 10, 3 times 12. That's a solid high intensity session to begin with. And then if you want to kick it up a notch, then you start cutting the rest in half. So you go from 30-30 to 30-15. Because now what's going to happen? You have less time to recover. Your bathtub has time to fill up in the 15 seconds again, right? That phosphocreatine buffer is going to build back up in that 15 seconds. So you can go again on the next one. And your VO2, your oxygen consumption, is going to climb more easily than on the 30-30s because 30 seconds is a lot of time for the body to recover and VO2 to come back down. And so if your goal is to build VO2, you want to spend time close to that maximum oxygen consumption. And so cutting the rest in half is actually very useful for that because we're going to accelerate the kinetics and it's going to go higher faster. And the famous Tabata workout, 20 on, 10 off, it's a VO2 max session, 2 units of work, 1 minute of rest. Originally, it was made for speed skaters, right? And 20-10, 30-15, 40-20, 1 on, 30 off, it's all the same. It's just trying to get your body in the right state to go close to your maximal oxygen consumption and spend time there and then build capacity and increase that number over time, right? And once we've gone to 30-30s, it could be 20-20s, it could be 40-40s. It really doesn't matter much. Then it's all about progression and all about the context of the person. Once you've done that, once you've cut the rest in half and you've progressed that a little bit over time, now we can start to go towards longer intervals, meaning 1.5 minutes, 2 minutes, 3 minutes, 4 minutes, right? Now it's getting real tough because there's no letting go for 15 seconds where you can recover, feel better, and then go again. So typically the straight sets, the longer one, 3 minutes, 4 minutes, are much, much harder on the body, much harder on the mind as well, and on the legs because there's no rest. It's just straight through, and you're in the heart, in the thick of it, right? But I would use that progression typically to go from 30-30s, 30-15s, and then 2 to 3 minutes, and repeat those for a number of times. And then you can get to the elite level. Like I went to visit my friend Seale that I mentioned before on the way back from the French Throwdown last weekend. We stopped on Monday with my wife in Provence in the south of France, and he was testing one of his cyclists. And they were doing 8-minute sets, and the first 4 minute of each interval was a little bit above the second threshold. So it's a high intensity 4 minutes. And then he would drop his power just a little bit to be just below the second threshold. So essentially, very hard for 4 minutes, and then still hard because you're tired and you've been doing it for 4 minutes, but we drop the power a bit so that he can do longer.
Mm.
right? And he was doing, I think, four sets of 8 minutes, which is a big session, which is very hard. So I wouldn't start with that, right? And again, I wouldn't start with a Norwegian 4x4, because I know Peter Attia talks about it, and a lot of people talk about that's the best session for VO2 max. That is a session for VO2 max, and that is a session that's been compared to others in one study, right? Or maybe multiple studies. Cool. But the reality is that if it was the best session, then everybody doing endurance sports would just do that session all the time, which is not the case, because your body needs variety, your body needs different stimuli, and you need to tailor your progression to the athlete, to their needs, and just again accumulate quality work over time. This is always going to be the refrain that's going to come back. This is what's going to drive adaptation. There's no single sessions, no magical sessions that's going to just change your fitness from one day to the next. It's just consistency and doing the basics, meaning having a good balance between the hard stuff and the easy stuff, right? The easy stuff just helps you do more hard stuff. That's really how those things play together. And I guess that covers the high intensity for now.
So when you do the long high intensity intervals, what sort of rest periods are you actually putting in? So say you're doing a
Good
three
question.
minute high intensity piece, how long do you need to recover to do it again?
I would do half to 2/3 of the work. So if you're
Okay.
doing 3 minutes on, I do 130 off, maybe two off. And there's always a trade off. Obviously, if you take longer rest, you can go harder on the next one. But then the drawback is you do a longer rest and your VO2 drops more, and it takes
Mm.
longer to bring it back up on the next one. So what are you trying to do? Are you trying to maximize the power you hold for 3 minutes? In that case, take 3-4 minutes off and then do it again, and you can hold a higher power. But if you want to just bunch it up a bit more and then have more of that VO2 stimulus, then you probably want to reduce the rest a little bit, right? And so the typical 4x4, 4 minutes on, 4 minutes off, 4 times. My friend David Lipman said, you know what, you'd be better off cutting the rest in half and doing 6 times 4 with 2 minutes off. You're getting more total work. You're getting more of the VO2 stimulus instead of just destroying yourself on 4 minutes 4 times, which is very hard. And it is going to pay dividends, especially when you're new to it. But eventually it won't be enough to keep progressing.
Very, very interesting. So would the only circumstances where you would go for a short work to long rest interval be when you're working on maximum intensity or speed because it doesn't confer so much fitness benefit?
That's essentially where we're going to go now with the very high intensity, right? So you saw it coming, and obviously when you're trying to work on your maximal sprinting power, for example, so you're on the bike and you're trying to just push as many watts as you can for a very short window of time, then you're going to maybe sprint for 10 seconds and you're going to rest for 1 minute and 50, and that way you can actually produce the same watts on the next one. Sure, you can start again, you could do 6 seconds on, 24 seconds off, but is your second rep going to be better or worse than the first one? What about the third one? What about the fourth one? And that's something I took from Derek Hansen, who's a really highly regarded sprint coach from Canada that worked with Charlie Francis back in the day. It's that if your rest is too short between sprints, you're just learning to be slow, right?
Mm.
For track sprinters, they want all their sprints to be within 2 or 3% of their peak performance, because once you start going to 95, 92%, well, it's too slow to actually be relevant for the 100%. So do you just want to be tired and fatigued, or do you want to actually sprint fast? So I would argue that for maximum power, if that's the goal of the session, then you want enough rest to be able to do it again, at least as good, if not better than the previous one,
Okay.
right? Now, if we think about sprint interval training like you're doing, 30 seconds all out, for example, on a 4 minute rest, well, the 4 minutes, nothing's going to be enough to cover the 30 seconds all out, because 30 seconds all out is super hard and you're just not going to be recovered. Maybe you need 20 minutes, 30 minutes, or maybe a day to do it again and push the exact same numbers, right? Um, but the goal is different. Here, the
Mm.
goal is to really challenge the body to its absolute limits, and you're going to have an increase in power over the first 6 to 8 seconds, and then it's going to start going down and it's going to start to hurt a lot all the way to 30 seconds. But obviously the aerobic stimulus on the body is going to be tremendous, because think about how you're breathing at the end of those 30 seconds, right?
Yeah.
You're close to VO2, if not there already, because it's an all-out effort and you have to recruit absolutely everything, and lactate is through the roof and oxygen consumption is through the roof. And there's a very strong metabolic buffering component of essentially teaching your body to deal with that metabolic acidosis, which is trainable to a short extent, right? But obviously you're going to significantly fatigue and recruit those fast twitch fibers and teach them how to use more oxygen faster, like we said before. And then the interplay between the fast twitch and the slow twitch, and how the slow twitch recycle what the fast twitch produce. So yes, you would flip to much longer rest periods. And again, we can argue for everything and its opposite. It's all dependent on what you're trying to achieve with the session.
Yeah, that's really interesting to.
And maybe to tie up that knot into a little bit of a bow, to bring in RPE again. I think RPE is fantastic all the way up to that short effort limit, where actually when you're doing a 10-second sprint, for me, RPE is not the best way to prescribe anymore. And it's going to rather be percentage of 100% effort that's going to be relevant there. So when I prescribe 10-second sprints, maybe 5 sets to Claudia, I'm going to say the first one is 85%, the second one is 90, then 95, and then the last 2 are 100%.
Yeah.
And that's how much she gives of her 100% on each one. Because again, 10 seconds all out is not going to feel very hard for somebody who's trained. It might be a 3 or a 4. And that number is not representative of the effort that we just did, right? So when you're doing really short sprints, I would talk in percentage of effort rather than RPE.
Yeah, that's useful. So yeah, it's just making me think of, like, if I was to do it all again, that seems like not the most efficient way for me to improve my ramp test score, because I wasn't able to do very much work because the intensity was so high. I was doing, so I'd do 30 cals all out, and I think I might be able to do the second one after 8 to 10 minutes.
Yeah.
And then the third one, I'd wait 15 minutes and my legs still wouldn't be functioning fully. And I'm like, I actually need to get this done because I don't have much more time for this session.
Yeah.
And yeah, like you say, it genuinely probably would have been a day before I could actually do the 30 cals in the same amount of time. So I could have accumulated a lot more quality work, which would have been closer to the ramp test intervals had I just dialed it down a little bit and used short rest periods instead.
Yeah, if your goal was to improve the results on the step test or the RAM test, then obviously the sprints have their place, and it's going to help you kind of squeeze out that last little bit on the last interval that you'll be doing in the test. But yeah, if you want to improve your results on the test, the best way to do that is to improve your thresholds. Get threshold 1 and 2 to move up to the right, and that's going to give you a better score in the end, right? Because you'll cross the second threshold boundary later in the test at a higher intensity. And we know that once you get into that high intensity, that's when the clock starts ticking, essentially, right? And you have that kind of reservoir that you can use up until there's nothing more. And then when there's nothing, there's nothing. And that's something that you can actually, going back to the Moxie, that's something you can see visually on the Moxie if you put it on a non-involved muscle. Going back to that homeostasis idea that we talked about before, low intensity, we have a balance at the muscle level. Medium intensity, we have a balance at the systemic level. High intensity, we lose that systemic balance. And so if you put a Moxie on the bicep or the forearm and you do that step test, once you go beyond that second threshold, you're going to start to see desaturation on the non-involved muscle because you don't have enough oxygen. Remember, I said second threshold is the tap is fully open. So the oxygen delivery is maximized. We cannot bring more oxygen to the muscles than we are actually doing. And so the body, what does it do? It doesn't have enough to feed what it needs to do. So it goes and grabs oxygen where it can. It goes into your arms. You don't need it there. Bring it over here. You don't need it there. Bring it over here. right?
Yeah.
So you have what's called sympathetic vasoconstriction. So your brain essentially just closes the blood vessels in your upper body and then redirects that blood flow to the legs where you actually need it. So for runners or cyclists that have felt their arms burn when they're doing a really hard effort, that's because you have no more blood and oxygen left in your arms because it's all been redirected to your legs, right?
That's definitely how it felt. Just zero oxygen anywhere in my body.
Yeah, exactly.
Yeah. Amazing. Cool. So I think that's an incredibly comprehensive summary of zones and prescriptions for stimuli. Is there? I think there's maybe one piece, I guess, that ties it all together is when you're profiling somebody in terms of their requirements. You've spoken about building the base broad and then peaking towards competition. Are there any other considerations when you're deciding the blend of the zones that you're prescribing to somebody?
Good question. There's an idea in endurance training called intensity distribution. So it's what proportion of your training is at low, medium, high, or very high intensity. And the two big ones, and I think they're the two most relevant ones for most people, are polarized and pyramidal training. So polarized just means that you have a high proportion of your training that's done at low intensity and another part at high intensity and very little in the middle. So very little medium intensity work, mostly low and high intensity, right? That's polarized training. And then the pyramidal work is a strong base of low intensity. That's the constant in endurance. And then a piece of the work at medium intensity, but very little at high intensity. Right. And for me, those are the foundations of endurance programming, meaning there's phases of time where we're going to be in the more pyramidal approach. The low intensity is like the constant. It always stays there to some extent. Obviously, at certain times of the year, if you're peaking for a non-endurance sport, you can put that volume aside. You can reallocate that volume, that training load to other things that are more important, but you can't get away from that forever. You're going to have to go back to it and rebuild the base at some point. But if you're in an endurance sport, low intensity is a constant in the program. It's always the foundation because it's just going to allow you to develop what we talked about before, the mitochondria, the capillaries, and the slow twitch fibers, which are the foundation of your metabolism and of your conditioning, right? So that's the constant. And then you're just going to bounce back and forth between more medium intensity training or more high intensity training, depending on the phase, pyramidal or polarized, based on your needs. So very concrete example, if you're prepping for a 5K run, which is typically going to be at high intensity, right? Far away from competition, you would use a more pyramidal approach with low and medium intensity training to build that base. So you do your zone 2 training, you would do your tempo moving up into threshold over time. And then when you start nearing the competition, maybe 10 weeks out, 8 weeks out, 12 weeks out, depends on the person, depends on many things, we would switch to a more pyramidal approach and, a more polarized approach. And now your medium intensity, the 2 sessions that you allocated each week to that development, they're going to move up at high intensity. And they're going to start going towards your race pace, right? And that's another distinction we can make is the general phase is we're going to be thinking about those intensity domains, about low intensity, medium intensity, high intensity. We're going to think about thresholds. We're going to think about kind of that raw foundation of physiology. But in the specific phase, we're going to think about race pace, right? Yep. Because now we're shifting focus from building the physiology to actually performing in the sport, right? If the race was won with your thresholds, then we'd all go to the lab, get tested, and whoever has the biggest one wins, right? Mm-hmm. That's not how it works. So at some point you have to shift and actually train for the sport, right? We made that mistake at the beginning of the year with Claudia, where we did 3 months of very general training for her, meaning only one CrossFit session a week, and all the rest was dedicated to building her running capacity, building her strength, posterior chain, because those are her limiting factors in general in CrossFit. And then towards Wodapalooza, we shifted towards CrossFit again. But she hadn't done CrossFit since the game, so it was 4 months without any CrossFit virtually. And we had She got sick in there for a week, so we had a total of maybe 7-8 weeks of CrossFit leading into Wadapalooza. And what she felt is that she wasn't ready for that big a competition with that amount of time. So next year, we know that the first time she goes back to competition, we probably need 2 to 3 weeks more of pure CrossFit in that specific phase before the competition, so that she feels better. Now, obviously, she's done this. Then we did another little general phase, but then we quickly went back into a specific phase because there was mayhem, and then there was the French throwdown, so there was no time in between to do any general stuff. Now we're in the season, we're full specific. Now she's taking 2 weeks off, and then we're starting again, going pretty quickly into specifics again, because then it's the games, right?
Mm-hmm.
So for her, there's 3 months out of the year where she's really in the general phase, where she really doesn't do much CrossFit, where we build all the stuff that she needs to then be able to perform at the best level in CrossFit. And so that, I would say those are the main frames that I would use for endurance training: pyramidal distribution, polarized distribution, and which one you use in what sequence will be determined by what you need and when is your next competition and what is your next competition, if that makes sense.
Yeah, that totally makes sense. And how would you adjust that? I know you've done a lot of work with MMA fighters as well. When you're preparing somebody for something that could be over in a minute, or it could be 25 minutes.
Mm-hmm. Very good question. I would always plan for the worst case scenario or the longest case scenario. So the MMA fighters, we know that their stuff is high intensity and it's very demanding, if for nothing else, than the psychological component. So they need to be ready to just give their life for 25 minutes, right? 25 is pretty long, right? And so the more capacity you can build behind that before going into the hard stuff, the better they'll be. And I know how hard it is in combat sports with shifting calendars, dates coming up really quickly, having to be ready from one day to the next. So you always have to keep a thread of that high intensity, I would say, to not be completely away from it for too long a time in case something just drops and in 3 weeks you have to be ready, right? But I would still allocate as much time as possible in the season doing the low and medium intensity, because you know that the camp is going to be high intensity. You know that the sport is high intensity in nature and very demanding on the body. So fitting in as much as the base as you can, so that when you do the hard stuff, you can do more of it, you can recover faster, and you can last longer.
Got it. And this probably covers both CrossFit and MMA. When you get to that high specificity phase going into competition, are you thinking about work to rest in the same way? Like, would you do 5-minute sparring sessions, then half that time to rest if you're like thinking about going 4, or is it all?
Good question. That's a good question. So since we've kind of gone away now from, because we're in this specific phase, if we call it like that, so we're just thinking about the sport. I'm not thinking about VO2 max anymore.
Okay.
VO2 max was in the physiological development phase, which is not the sport, right? So the work to rest ratio, I would think about in the phase where we're trying to develop those qualities. But once we're shifted onto the sport, now is what do we need for the sport? And if you need to be good for 5 minutes and then recover in 1, then train that. But it's almost going to be more about habituation, getting the athlete ready for that type of frame, so that it's not completely new when they get to the competition and they've done it over and over again. That's also how the body and the mind adapt, right? Same as take an example of a cycling race, right? If all you've done to prepare is threshold intervals, tempo intervals, and VO2 intervals at constant intensity, but now you start a race and it starts out fast and people start sprinting in the first 2 minutes, guess how your race is going to go? Not so well, right? So once you get into the specific phase, and for those who are interested in endurance sports or endurance concepts in general, there's a really good YouTube channel, a guy called Dylan Johnson. He rides in gravel racing, and he's very open about his training and what he does, and it's super interesting. And he talks about how he prepares specifically for those long 3 to 4 hour races that he does. The specific sessions are going to include 20 minutes really hard at the beginning, then a bunch of work, then a bunch of intervals, and then at the end, another 20 minutes super hard, right? Whereas in a typical session, you would do your warm up, you would start easy, and then you would do your sets, and then you would cool down on the back end. Well, in an actual race, it's the opposite, because where you are in the field is going to dictate to a high degree if you can keep up with the guys in the front or not. And if you can't get to the front in the first 20 minutes by pushing crazy power, you're never going to win or even get a chance to be in the conversation. So you need that 20 minutes at the beginning, and you need the 20 at the end to finish strong, right? And you need a bunch of stuff in the middle, depending on terrain, depending on your competition and everything. So really being able to shift between, I want to build the physiology, I want to build the foundation, and then shifting to what is the sport requiring me to do, and then just becoming elite at the sport itself and the competition itself, and not just be a master in training physiology, but then losing the plot when it comes to the race.
Yeah, that's super cool. And I think for the MMA thing, the other side of it, a fight, is that you can also dictate the pace. So if you are a bit gassed, you can slow things down. You have that option. Whereas in a endurance sport race, other people dictate the pace to some extent. So you have to be ready for what they put on you. One question I thought of earlier that I didn't ask was, I think you've kind of answered there, is that where you see the application of fartlek training? Because it has varied speeds and durations. It's not a very elegant tool for targeting VO2 max compared to more consistent intervals. So is it just better for race replication?
It could be, if your race looks like one of those.
Yeah, not many races.
No. It could also just be a way to train and have a bit of fun.
Okay.
Because sometimes you just need to do the work, and sometimes it gets taxing to just, I've got to always do this for that and that for this. And sometimes you just want to move and you want to train. And maybe you had planned a tempo session initially, but if you do a fartlek session where you do a few bouts of running faster and a few bouts of running slower, and then something in the middle, and then you build a good volume over the session, it's just as useful as doing a very structured lactate controlled tempo session, right? So in the end, all roads lead to Rome, and you just have to know what you're trying to do. And again, some people are able to operate without those concepts of thresholds and without the testing, without the numbers, and without the lactate. All you need is a stopwatch and the coach's eye, and a good understanding of training. And I think most importantly, as well as a coach, is understanding your athlete, knowing what questions to ask, and knowing when it's good, knowing when you have to pull on the reins a little bit. I think that's the other side that we didn't touch on. And everything we talked about is, I think, important to at least consider, if not understand, if you want to plan endurance training and if you want to do it in a coherent way. But then the other side is the human aspect, the communication aspect. And this is where the rubber meets the road, essentially. And you can be the best technician on all the stuff we talked about, and you can measure all those things to the watt. If you don't know how to communicate with your athlete, if you don't know when to notice that it's a bit too much for them and they're not recovering like you had planned, and you have to pull back on training, or you have to get them to take a week off, and if you can't do those things, then that's going to be a big problem. So I think you need both sides, right? It's the science and the art of coaching. We talked about the science of endurance. I think the art of coaching is just as important, if not more important, in this global conversation. Maybe a topic for a future podcast.
yeah. I think we'll have to set aside a week in the diary to to do part 2. I think that's we've gone into so much detail and depth, which I love. But I think coming back to that frame of, we're just trying to accumulate as much quality work as possible.
100%.
And that answers almost all the questions. Like, yeah, you can go more intense, but if it compromises how much total work you're able to do, then it's probably not going to be better than working a little bit easier, but doing more of it.
Or it's better because you've only done the medium and the low stuff for a while and you need the high stuff, you know? So again, what have you done for the last 2 months? Who are you? What are you made of? When are you in the season? When is your competition? What are you trying to achieve? And what are the demands of the competition? All those questions give you almost everything that you need. And then we always think about, I got to write a plan for X weeks and all that stuff. But you need to know where you're going. You need to have an overall plan. But the plan isn't detailed until you get to that month or that week, right? It's just, okay, we're going to go in that direction, like ballpark. This is where we're going. But exactly which road I'm taking, I can't see the damn road, right? I can see there's trees like a kilometer away. There's trees, there's buildings. I don't know which road I'm going to be on, but I just know I'm going over there. Once you get there, okay, you can pick the road. I'm going left. I'm going right. What makes the most sense? But not trying to plan too far ahead while having a clear direction on what you're trying to do, and then being adaptable week to week, month to month, based on the feedback of the athlete, based on are they responding to training like they're supposed to, and that's going to be the kind of the day-to-day process of applying the coaching itself. And it's tough. It's tough because we want to think that we're machines and we want to write something on paper and say you get to do it like this. And most people have a hard time saying, well, I didn't feel well, so I didn't do that, or I didn't feel well, so I only did 1 instead of 3, or I did half the intervals because I wasn't feeling great, or I did 20 watts below what you said because I needed to go easier. But typically what I see is that athletes that can listen to themselves the best and regulate their training accordingly last the longest and have the best performances as well. Because it's not about what's written on the paper. It's about getting the right stimulus and doing the right thing in the context that you can actually do it that day. But if you can't, then we need to change the plan. Then we need to maybe scrap the training, maybe do something easy instead of the hard stuff, maybe do a little bit less of the hard stuff, or maybe push it back into the week and do something else instead today so that we can actually get the quality session, but you didn't sleep, your kid was up, blah, 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 and today's not the day to do it. And that's some other important considerations when it comes to actually getting the most of everything we've talked about earlier.
Amazing. I think that's a really nice place to wrap things up. Thank you so much, Sean. Could you tell everyone where they can learn more from you? Because I'm sure there's a lot of people whose interests have been piqued, and I know you've launched a new offering. Can you give us a bit of detail, please?
Absolutely. Thanks, man. So academy.upsidestrength.com is the platform where I have different programs, different courses. For coaches that want to go deeper, I'd highly recommend starting with the RPE method, which is a small, easily digestible mini course on RPE and on how to use it in endurance training, strength training, sports in general, how to test with RPE, how to monitor volume, training volume, especially useful in sports like CrossFit or when there's multiple disciplines that you have to blend together because you can't use heart rate on strength work, but you can use RPE on any types of session. And there's actually a spreadsheet that I built where you can log all your training and have a nice dashboard that tells you, how much you trained and are you recovering properly based on what you were trying to do. So that would be the RPE method. And then for those that want to go farther, I haven't launched it yet in English, but I'm on my second season of the Endurance Mastermind in French at this point in time. It's a 12-week guided program with theory, with a lot of exercises and a lot of calls with the group so that we can learn all those concepts around endurance programming and know how to apply them in different concepts. The email list or the pre-sign up list is being built on the English side. I think I have 8 or 9 people interested already, and obviously needs to reach critical mass before I can launch that one in English. But I look forward to be able to work with more English speaking coaches and try to keep spreading those ideas. And I really think that, and thanks Ash for the opportunity today to chat with you. I think that it's through sharing that we learn. For me, that's 2.5 hours of trying to explain things clearly. And it's a really good exercise. And so that's what we do in the mastermind. We try to exchange with the group, answer questions for others. I don't do all the answering so that we can really work on seeing if we understand things. I think one of the big problems in the world today is that nobody wants to be wrong. But it's by making mistakes that you actually learn. You learn much faster that way. So not being afraid to try, to share, to do the exercise, to try and have the answer, even if you're not sure, is a fun way. First of all, to work with a group of people that have the same aim as you, which is just become a better coach and know how to wrestle with those endurance concepts, whether it's for endurance sports, CrossFit, or even for strength sports. So that's all on the academy. And otherwise, there's obviously the podcast, Upside Strength podcast. There's now the English YouTube channel where I do dedicated English content and social media in general, where you can find me.
Amazing. Yeah, I'd highly recommend checking that out. And I think if people didn't know before the podcast, the fact that you speak about this stuff in the incredible level of detail that you do in both French and English, I think needs a round of applause silently
Thanks,
as
man.
everyone listens to the podcast. It's phenomenal.
I appreciate it.
Yeah, thank you so much for your time. We've gone way over, but I'm sure we could even keep talking for another 2.5 hours for all the other stuff that we want to do. But yeah, I want to respect your day and let you get back to other things. But thanks again, Sean. And hopefully we'll have another podcast at some point in the near future too.
Anytime you want, man. Thanks so much.
Thank you for listening. If you're still with us all the way to the end, I appreciate your perseverance, but hopefully you agree with me in that it was well worth it. This is certainly one I'll be re-listening to and making notes on to really absorb all the details and takeaways, which, yeah, I think are incredibly powerful when applied intelligently. Thank you again to Sean for sharing such expertise with us. Genuinely feel incredibly lucky that I get to call this work, just to chat to you and learn from your amazing knowledge and experience. And if you guys enjoyed it, please let us know what your most useful takeaway was in the comments, or if you have any follow-up questions, we'd love to hear those as well. Please drop them in on YouTube or Spotify. But that's it for this week, guys. Thank you for your time and attention. Everything else you need to know will be in the description. But otherwise, take care and we'll catch you next week.